Hello everyone and very good morning. Welcome you all to the session. I hope I'm properly audible to all of you. Very good morning and welcome to this session. So yesterday we started off with the workshop and we have seen sort of idea of introduction to artificial intelligence, machine learning, and deep learning. In the mid somewhere after the break, we couldn't continue further because of the issue with the portal. But yeah, today we have changed the portal and we're expecting it to go smoother. Right. So, let's get started. We'll be resuming further from where we ended yesterday. So yesterday we have so far seen the idea of artificial intelligence, and it's more of uh, making computers act intelligently, or you can say making computers imitate intelligent human behavior. Technically, AI is about collection of algorithms, and those algorithms are proven, tested, popular ones. Some of the algorithms which make use of data are part of machine learning, and some of the algorithms which perform automated feature selection, feature extraction are part of deep learning. Deep learning is more advanced compared to machine learning. We discussed that machine learning is the idea of making machines learn from experiences, like the way humans do, and for them, experience is data. Right. We discussed about the applications of ML, which includes financial predictions, predictive maintenance, churn predictions, chatbots, face recognition, sound recognition, speech recognition, self-driving cars, web click record, data mining into that, and machine translation. These are a bunch of applications we discussed in detail. A couple of other applications we discussed about machine learning. We also talked about which programming language is a better programming language for implementing ML solutions, which is Python, and the other option is R. We also talked about a couple of cloud platforms. And then what should one learn when it comes to learning machine learning? Post that, now we're going to start with the types of algorithms under ML. As we discussed that ML is consisting of bunch of algorithms, or you can say that ML is consisting of algorithms from AI which consume data. Those all algorithms which are part of ML can be further categorized into supervised learning, unsupervised learning, and reinforcement learning. As a part of today's agenda, we are going to start with this topic, then talk about set of problems that we get under supervised, unsupervised, and reinforcement. And after that, we are going to work with one of the supervised learning algorithm, which is linear regression. We will understand the maths behind the algorithm, the logic behind that, when to use it, and we will be able to see one of the real world use case on the same algorithm. So let's get started. These are three types of machine learning algorithms. The first is supervised learning. Well, as we discussed, whenever it comes to that, you want to make prediction, right? Whenever it comes to predicting future, right? Whenever the objective is about predicting future, or maybe you want to get a task done by the algorithm or a computer which you know, right? So you know the objective of the task which you want to get executed by the algorithm. In those scenarios, you should uh, refer to supervised learning. Supervised learning algorithms always require labeled data, right? They learn always from labeled data. That means they want to have features and the label separately available, right? And the algorithms are trained from the past data, and a trained model is deployed in production. In case of supervised learning, we train the model using past data business, and only a trained portable file is deployed in production. So the model doesn't learn in production, right? Once you train a supervised learning algorithm and you deploy it in production, it doesn't learn. We discussed one example, like you might have seen the Android smartphones, and specifically let's say MI smartphones. In that, when you open front camera, you get an option of age prediction. The uses a square box to represent our face, and also it presents, or it you can say it shows the age of the all uh, people who are looking into the front camera above the box, right? So it simply does the age prediction of the part, you can say users, customers. That means that should have been maybe a supervised learning trained model. The model would have been trained with like what? The data like this. Let's say face and age is 29, face age is 24, face age is 34, face age is 39, and like that we have face data and the age. And with this data, it would have been trained. And now, whenever we see in the smartphone, the model, a trained machine learning model, makes a prediction of how old we are. This is what you call label data. You can say the face is the data, and this is label. And the trained model is deployed in our smartphone, which is a production environment for the model. And the model doesn't learn in the smartphone, right? So whenever it makes a prediction for our face, it doesn't make any learning, right? So that's the idea of supervised learning. In case you have any question, you can make use of the question box available on the right hand side, or also the chat box available on the right hand side as well. Okay, and I hope I'm audible to all of you properly, right? And in case, because I'm audible to other participants, in case there's some audio issue at your end, kindly check the network connection. Okay, so well, that's idea so far about supervised learning. So as we discussed, in a nutshell, the idea of supervised learning is whenever you want to predict future, go for supervised learning. So set of algorithms supervised learning has can be used to predict future. And the example of supervised learning could be, let's say, whenever I know the objective, what I wish to achieve with the model, I can go for supervised learning. For example, I know that I want to develop an algorithm which should be able to predict whether customer will leave or not leave. I know that I want to get an algorithm, or I want to get a solution which should be able to predict whether customer will buy the product or not. I want to predict whether machine will get damaged or not. I want to predict the stock prices of Tata Steel stock tomorrow. I want to predict the uh, fare of a ride if I take from Ola from point A to point B. I want to predict whether flight will be delayed or not delayed. I want to predict flight will be delayed with how many seconds. These in these all cases, we know the objective and what we wish to achieve, and that's what we whenever these situations are there, we always reach out to supervised learning algorithms, right? So in a nutshell, supervised learning algorithms can be used whenever you wish to predict future, or you know what you want to achieve. We always feed labeled data, and the model learns from past data. Only a trained model is deployed in production. That's idea of supervised learning, right? So machine learning has a lot of algorithms. Some of them are part of supervised learning. Supervised learning is very popular, and in most of the cases, you're going to deal with supervised learning algorithms. The next is unsupervised learning. Well, uh, furthermore, the understanding between supervised and unsupervised will get clear in next couple of slides. We'll discuss variety of examples to understand both. Unsupervised learning, contrary to supervised learning, is not used for prediction. Rather, it is used for pattern recognition, recognizing patterns from the data. And we always feed unlabeled data in unsupervised learning. The model learns in the real-time production, so it is very expensive set of algorithms in production. Let's understand the idea of unsupervised learning with an example. So let us say that we wish to understand the idea of unsupervised learning, right? So let's say that we have a set of objects here, right? This is one of the object. This is one of the object. And let's say This is one of the object, right? And then this is one of the object. This is the one of the object. So the question is, how many groups can we form out of these six objects? How many groups can we form out of these six objects? Right. The question is that how many groups can we form out of these six objects? Right. You can put your answer in the question box, or else you can use the chat box as well. Right, so we have a couple of answers. Well, groups, right? When we say groups, like we're not talking about permutation combination, but yep, you can say that. Well, maybe two or maybe three or four, right? Well, we can form two groups or three groups or four groups as well, right? What could be the basis? So, well, you can say that maybe all these objects on the top, first row are elliptical in shape. So based on the similarity in shape, you can group them together, right? So they are grouped based on the similarity in shape, and these are rectangular in shape, so they have similarity in shape also, right? So based on the similarity in shape, we could find two groups. Similar manner, you can say that these two objects are horizontally spread, right? These two are vertically spread, and these two are almost uniformly spread, you can say. So based on the similarity in spread also, we can find three groups here, right? So we can get two groups also, three groups also, maybe other set of groups also we can observe here. But the idea is that uh, this process of grouping is called as clustering. This process of grouping is called as clustering. Clustering, or making clusters of objects, right? Making clusters in the sense groups of objects, categories of objects, right? So what we did here is, based on the similarity into the observations, based on the similarity into the objects, or you can say the figures, we grouped them together, right? This is something where we call, what we call as pattern recognition. We are able to recognize some set of patterns from the data. We are able to recognize some set of pattern from the data, right? Based on the similarity into the figures over here, we are able to categorize them, and that's how we are able to recognize pattern. Pattern recognition is what we call as unsupervised learning. In order to understand it much better and being able to relate with real world complex, real world concept, real world scenario, let's take a couple of examples. In general, the first idea is, the basic understanding is, clustering is one of the problem in unsupervised learning, and it's more about grouping of observations based on the similarity into the features, similarity into the objects. Let's say the feature could be shape or maybe the spread, right? Based on similarity into these features, grouping them together. Let's take an example. The way we have grouped them based on the similarity into the feature, the same way we're going to look at an example. If you look at an example of news.google.com, so Google doesn't have journalists to write news articles on their portal, right? They don't hire journalists, or they don't have even any journalist who can write news article on their portal, right? So what they do, well, here comes a machine learning algorithm. They use machine learning algorithms, supervised, unsupervised, both. First, we're going to look at an example of unsupervised algorithm, which does the job of which handles the job of news portal. So this complete news portals is handled by machine learning. Well, when it comes to gathering news, you cannot predict, or you cannot use supervised learning to get news articles, because in supervised learning you do prediction. You can't predict the news can never be predicted. So what they do is, they use pattern recognition. That means what is happening right now, recognize that pattern and bring it on Google, right? So the algorithm checks thousands of news websites based on the similarity into the headline, similarity into the content, similarity into the images, and the places, time of publishing, location of users who are reading it, it groups them together. So you can see that here we got one group, approach with white flag and take back dead bodies from News 18. LOC hots up again. Times of India, Park infiltration blocked, NATV News, Army foils infiltration, News 18 and BRE Squad, Times Now. Well, these are multiple news articles which have similarity into headline, similarity into the content, grouped together much more the way we have done this. The same way Google, this algorithm is doing grouping of news articles and bringing it to us, right? It has looked into the similarity into of news articles. So here, instead of images, like the way we had images here, news articles are the objects. And between every object or observation, the similarity into headlines, similarity into content, images, places, location, nouns, pronouns, not pronouns, mostly nouns, is grouped together. The same way we can see here also. Jammu Kashmir 10th troops arrive, outstation students asked to leave valley. Times of India, the Indian Express, NTV News, the Quint, right? These are multiple news articles grouped together, right? And NTV News, News 18, Times Now, Hindustan Times, NTV News 18, CBS News, the Indian Express, right? And Z News, First Post, NTV News, Times of India, like that. So the algorithm has grouped multiple news articles together. And this grouping of news article is completely unsupervised learning. The reason for using unsupervised learning, because you can't use supervised learning, because you can tell the algorithm that I want you to pick this news. You don't know what will be news in next 1 hour. So you can't predict that. You just have to recognize patterns. That's the idea of unsupervised learning. So you can say that here's an unsupervised learning algorithm playing the job, doing the job. Well, what could be the other examples of unsupervised learning? The other examples of unsupervised learning could be recommendation system. Whenever I reach to Amazon, right, if I search for a product on Amazon, I get multiple recommendations, right? Product recommendation on Amazon. People who are buying this product are also buying this product as well. This is nothing but pattern recognition. Recommendation system is also an example of unsupervised learning. If I go to YouTube, I'm watching a Salman Khan movie, I might get recommended, or maybe a video, I might get recommended that, well, those people who are watching this or who have seen this particular video have also seen this video as well, and you might like this, right? That's nothing but pattern recognition. Friend recommendation on Facebook, video recommendation on YouTube, product recommendation on Amazon, movie recommendation on Netflix. These are all recommendation systems and fall under unsupervised learning, pattern recognition. Unsupervised learning always requires unlabeled data, and these algorithms learn in production. Imagine this Google News example. Google will have to run this model or train this model maybe every 30 minutes, because every 30 minutes the news will keep on changing, or maybe every 1 hour news will keep on changing, right? So they might need to train this model every 1 hour or every 30 minutes. YouTube will need to run their model every day, once in a day, and that's very expensive. All the unsupervised learning algorithms are almost near real time, and that's how they are very expensive in production. So that sort of idea is about unsupervised learning. It's used for discovering patterns and always accepts unlabeled data. And the idea of unsupervised learning is categorization of objects or the documents, or maybe the observations, the customers, based on the similarity into the data, similarity into the content, right? So there is a question to repeat supervised. So idea of supervised is used to predict future, right? And it accepts labeled data, and we train the model from past data. We deploy a trained model in production. In production, it doesn't learn. So whenever you know the objective, what you want to achieve, you go for supervised learning, right? For example, I know that I want to get a model to predict uh, whether customer will leave or customer will not leave. I know I want a model to predict whether will customer will buy the product or not, whether tomorrow there will be rainfall or not, whether flight will be delayed or not delayed, whether I will win the game or I'll not win the game, whether I'll particularly, let's say, uh, machine will get damaged or not get damaged. In all these situations, we know the objective, what you want to achieve. You go for supervised learning, right? And model learns the pattern. Based on that, it makes prediction. There's a question. When you say label data, what do you mean by that? Well, you can look at this example. For every customer, we have features like row number, customer ID, and tenure, balance, number of products, has credit card, exact number, salary. These are set of features we have for every customer. And at the end, for every customer, we have the answer or label, that is customer left or did not leave. So this is what you call as label. That means we want to build a model to predict customer will leave or not leave, but for the past data, we already have those answers. So when you have the answers for the past data, those answers are called as labeled. That means if I want to build a model to predict whether customer will leave the bank or will not leave the bank, but for the past data, that means for past customers, I already have the answers, whether they left, they did not left. Those answers for the past customers are the labels. I can train the model with label data. The model can identify when customer live or when do not live. And then that's how they can predict. The same way, when it was about age prediction, the faces are the features and the age is the label. The model is trained with the face and age, and it will be able to identify when to predict age and how to predict age like that. So that's label. Supervised learning accepts always labeled data. Unsupervised learning accepts unlabeled data. I hope that answers the question, Akshat. There is a question, why unsupervised learning is expensive more than supervised learning? That's a good question. Sanjeev, in supervised learning, we deploy a trained model in production. The model doesn't learn anything in production. For example, in the MI smartphones, you might see the age prediction, right? So it's a trained model deployed in smartphones. When it predicts our age, when you look at the front camera, it predicts our age. When it predicts our age, it doesn't learn from our age. It was just trained with the past data and it does the prediction, right? So all supervised learning models do not learn in production. They are just a trained model like a DLL file or any portable file, and they are deployed in production. Whereas unsupervised learning models, they learn in production. Imagine Google News. They will need to train this model every 30 minutes. That means they are training the model in production itself. In production, that means live. When the model is live, there itself it is doing learning, right? Recommendation system on Amazon, recommendation on YouTube, or Facebook friend recommendation, Netflix movie recommendation, all these models learn in production in real time. That's how they are very expensive. Google News, if they have to train the model from millions of news articles, it will be very expensive. The amount of RAM and processing speed, the computational infrastructure required will be very heavy for production environment for unsupervised learning compared to supervised learning. So when we say expensive, the meaning of expensive is that it will require more computational cost, RAM, processing speed, like that. I hope that answers the question, Sanjeev. There's a question on having said about labeled structured data. Can you explain more clearly about an unstructured and semi-structured data? Unstructured data is like social media data, like the data that you upload on Twitter, let's say, right? For example, I can say that an unstructured data could be Anshu 45, and let's say I live in Surat and India, data scientist, and date of birth is 12/13/2019, something like that, right? And Jack and 45 and London, and then we have let's say John 78 and New York, right? So we have unstructured. There's no tabular format for this particular data information given out, right? Or let's say that I am Anshu living in London and I am a data scientist. This is unstructured data, right? The information is given, but it is not given in tabular format. So this information cannot be processed as it is. So we call it unstructured. This is completely unstructured, and this can be called as sort of semi-structured data because there is no irrelevant information. This data is easy to convert into tabular format. This data is difficult to convert into tabular format, right? So when the information like you collect from social media, from internet, from web pages, right? And from essay, from applications, right? From books, in those situations the data is completely unstructured or semi-structured. And to process such data, we make use of regular expressions, and there are some other techniques with Python packages available to handle such scenarios. I hope that answers the question, Soumya. Uh, SRQ, we are not going to take that algorithm in this uh, workshop, so I will not be able to cover that topic in this workshop. We have a pre-decided agenda, and we'll only be able to stick to that. Okay, so well, that's about sort of unsupervised learning. Let's talk more about supervised and unsupervised. For example, here you can see that let's say that we're talking about an intern who is doing internship after MBS, right? And the intern is getting to work under senior doctor. So let's say that this girl is the intern who is doing internship in the hospital, right? This girl is the intern, and this guy with a broken hand is the patient. And when this guy comes to hospital, he brings a lot of reports, right? Those reports could be blood test, maybe any other test, CT scan, X-ray done by the patient, or I mean done by some other executives and for the patient. So this patient is bringing a huge amount of data to the hospital. The doctor is going to take this data, right, study this data, and going to give treatment in return. What intern is going to do, intern is going to keep on learning that, well, if this is the patient's data, this treatment should be given. Intern is going to keep on learning the relationship between the patient's data and the treatment. So you can say the patient's data is a set of features, and the treatment given by the senior doctor is the label. So intern here is learning from the labeled data. And till 2 years, intern will keep on learning, and after 2 years, intern will do predictions like a senior doctor. So this is what we call as supervised learning, right? The intern here is learning from labeled data, right? So the you can say the patient's reports are the features, and the particular treatment given by the doctor is the label, right? So if I repeat again this, you see, let's say that there is an intern who has done MBBS, and after doing MBBS, what they do is they go to hospital to take an internship. So let's say that this girl is an intern, and this guy is the patient, right? And this guy is senior doctor, right? This guy is senior doctor. So when patients come to hospital, they bring a lot of reports, right? And what senior doctor does is senior doctor study that report and gives the treatment. But what this intern is going to do, intern is going to keep on learning from the data brought to the hospital by the patient, and also the treatment given by the senior doctor. So intern is going to learn that, well, whenever this is the situation of the patient, this treatment should be given. Whenever that is the situation of the patient, that treatment should be given. So intern here is learning from the data bought by the patient and the treatment given by the doctor. So here the data bought by the patient is the set of features, and the treatment bought by the doctor is the set of the treatment given by the doctor is the label. So intern here is learning from the labeled data, right? Intern here is learning from the labeled data. I hope you're good with that, right? So this is what we call supervised learning, right? When the learning is made from the labeled data, this is what we call as supervised learning, right? So I hope you're good with that. Okay. Next is if you talk about a scenario where there is no senior doctor, right? If you talk about scenario where there's no senior doctor, that means there is no label. Now the patient come from, patient come with a lot of reports. Let's say that intern is analyzing the patient's data, right, without the doctor's treatment. That means without label, unlabeled data, right? And what intern found is that, well, let's say the patients are coming from certain locations in Hyderabad, and those locations are, let's say, Chandanagar, and this location is, let's say, sort of Amirpet. These are locations in Hyderabad, and let's say that this location is sort of uh, anything like maybe uh, yeah, high-tech city, right? And we have patients, these patients have cold, cough, and fever. So what in turn is analyzing that, well, when it comes to relating between the location of the patient and the disease that they have, the complaint that they have, it turns out that, well, majority of the patients who visited the hospital today are from high-tech city, and majority of them have fever. So intern is able to identify a pattern here that, well, out of the all past patients visiting hospital today, majority of the patients who are coming from high-tech city are having fever. That means there's something wrong happening in high-tech city, and that's what a sort of pattern can be recognized by the intern, right? So intern for recognizing this pattern is not making use of label data, right? There's no label available over here. Intern is just comparing multiple features, and based on the comparison on multiple features is able to come up with a pattern. This is what we call as unsupervised learning, right? So the idea of supervised learning, you feed labeled data and you make predictions. Unsupervised learning, you feed unlabeled data and you do pattern recognition, right? A little more example, if we talk about, I might not have here, well, maybe need to, yeah, I may not have it here. So, well, that's sort of idea of supervised versus unsupervised. So let's say that if I ask you a couple of questions, and uh, one of them is, if I have to, let's say, build a model to predict whether, uh, let's say, whether particular flight will be delayed or it will not be delayed. So is that a supervised learning example or unsupervised learning example? I want to predict whether the flight will be delayed or it will not be delayed, right? So we want to predict whether it will be delayed or it will not be delayed. So it's an example of supervised learning, right? Because we know the objective, what we want to achieve, and the predict word comes into picture. That means we are making prediction. Okay, another question. Let's say if we want to know the spending behavior of customers coming to a particular retail store, right? So let me explain the use case much better, right? So there's a retail store like DMart, or let's say Big Bazaar, or let's say uh, the more more retail store, right? Like that, right? So the idea is that the manager needs to decide one offer this Diwali or this Raksha Bandhan, and that should suit majority of the customers who visit the portal. I mean, who visit the store. Though then the manager, in order to decide the offer, needs to understand on what product the customers spend more and on what product customers spend less, and which product in their area is more popular and which product is less popular. So they need to recognize the spending behavior pattern of the customers coming to the store. To recognize the spending, the pattern of spending behavior of customers, they should use supervised learning algorithm, or they should use unsupervised learning algorithm, right? So to recognize spending pattern of behavior of customers, how do they spend the money, on which product they spend more money, on which product they spend less money, and what makes they spend more money, how to make them spend more money, like that. So that's sort of pattern recognition, and that could be done by an unsupervised learning algorithm, right? So there are variety of scenarios where we use supervised learning, unsupervised learning as well, right? And yeah, so this was an example of unsupervised learning. So I hope you have slight understanding, good understanding of supervised versus unsupervised. So there are a couple of questions in the question box. Let me quickly take them, and then we'll shift to the third one, which is reinforcement learning, right? So there was a question, uh, does NLP follow supervised or unsupervised learning? Well, NLP uses both of them, right? If I have to do ticket classification or email classification, it's supervised learning. But if I have to recognize on social media what people are talking about today, that's unsupervised, right? And based on previous weather conditions, we can say it's an example of supervised learning, right? Yep. So yeah, that's idea so far about supervised and unsupervised. The third algorithm is reinforcement learning, which is less used. Here, the algorithm learns from the feedback, right? Let's take an example. So reinforcement learning is used when the data is not sufficient to train the model. For example, if I have to develop a model to play intelligent chess, right? Or if I have to train the model for chess playing agent, I have to develop a machine learning based, you can say ML based chess playing agent, right? In that scenario, I have to develop ML based chess playing agent. That means one agent or algorithm, which can play chess, right? So if I have data of 100 games of chess played by two people, let's say two people played by two people, right? 100 games, I have data of 100 games. So you can say in those 100 games, somebody would have won the game, somebody would have lost the game. If I train the model with such data, the model will learn 100 ways to win the game of chess, right? If I train the model with such data, the model will learn 100 ways to win the game of chess. When I deploy it to production, that means when I make it to play against a human, is it necessary that always the game will go according to what it went in those 100 games, as it is step by step, and the model will win the game? Is it necessary that the game will go as it is, as it has learned from the previous 100 games, and every step by step will be as it is, and model will win the game? The algorithm will win the game of chess against human. If the algorithm is trained with 100 games of data of 100 games, past 100 games played by humans, and we have trained the model, right? We have trained the machine learning algorithm. Now we make the machine learning algorithm play against human. Now, when we make it play against human, is it necessary that every step or step-by-step approach is going to go as it is, as it went in those 100 games, and the machine learning algorithm will always win the game? Will that be possibility, right? So we can say that, well, that's not going to happen because the game of chess is completely unpredictable, right? You can't predict next step, and you can't have a pre-stored strategy. So in the game of while playing game of chess, you can't come with a strategy that I will do this step, the opponent will do this step, and I will do this step, and I'll win the game. This will not happen always, right? You can't come up with a pre-stored strategy in the game of chess. The strategy has to be built on the go within the game itself. Every step the strategy has to change. That's where supervised and unsupervised learning algorithms do not work for such situations. And that's where we use reinforcement learning, which is feedback-based learning. What do we do in such situation to train the model? Well, to train the model, we define that every time the model is going to win, it will get a positive reward. And every time it is going to lose, it'll get a negative reward. We then create a maximization equation to maximize the positive reward. Let the algorithm play the game of chess hundreds and hundreds of times. Every time it wins, it remembers that whenever I'm at situation ABC, this is how I can go towards winning. Whenever I'm at situation XYZ, this is how I can go towards winning. Whenever I'm situation at EFG, this is how I can go towards winning. It identifies all possible permutation combinations how to win the game of chess. And that's how we get a trained model. But training a model with reinforcement learning takes days and weeks and months as well. So it's widely used in game development. A lot of people who have developed such games, it takes them weeks and weeks to train such models. Reinforcement learning is heavily used in game development, space research, and defense research. One of the real-time example of reinforcement learning is Google Maps. Google Map uses supervised, unsupervised, and reinforcement, three of them. Let's say if I want to predict tomorrow, right? One of the example of supervised learning with Google Map. If I can show you that, right? So on the Google Map, if we see traffic, so how do we get to know that traffic is heavier at a particular place, right? So let's say if I currently look at from my location, which is, let's say, Richmond Road, Bangalore. From this location, if I have to travel to the other location, let's say that's Kormangala, Bangalore, or Electronic City, Bangalore. And if I look at traffic here, so you can say that it is doing prediction of a time, how much time it will take for me to reach from Richmond Road to Electronic City. And this prediction is what we call supervised learning, because it is predicting the time taken by the the vehicle to to locate from one to another. What are the features? The starting point, ending point, distance, and I'm traveling by car or bus, or we can say here walking or cycle, maybe like that, or flight, right? Other than that, unsupervised learning is where you can see the patterns here, right? You can see the patterns here, the traffic patterns. These traffic patterns are more of unsupervised learning plus reinforcement learning. For example, the usual traffic patterns, right? The real-time traffic pattern, if I look at real-time pattern of out of this, right? If I get the direction from this and let's say sort of I look at Electronic City again, right? So if I look at these patterns where there is a heavy traffic or there is a very heavy traffic, these patterns are nothing but the patterns observed by the people who are currently traveling. So if I'm moving in front, or if I'm moving on a particular road, right? So if I'm moving slowly, I'm generating data that there is a huge traffic here. If I'm moving faster with Google Maps switched on, I'm generating data that there is a less traffic here. Based on the speed with which I move, I'm generating data there is a huge traffic or there is a less traffic, and the person in my backside will get more accurate result or more precise result because I'm using Google Map. So the more we use Google Map, the more data or feedback we generate, the more accurate it becomes. So that's an example of reinforcement learning. It learns from the feedback that we generate, right? So the more we use it, and slowly we move or faster we move, we are generating more amount of data, and that's how it is learning that whether there is a huge traffic or not huge traffic. And if I can predict here that if I depart at instead of Sunday August 4, I can depart at 7, and what will be the traffic at that time. So this is more of supervised learning. And if I look at the pattern over here of traffic, this is not real-time pattern, but this pattern is observed based on the past data, which is unsupervised learning, right? So Google Map heavily uses reinforcement learning for real-time traffic prediction, of how much traffic is happening at what position. It's more of feedback-based learning, right? Other examples of reinforcement learning are used in space research and defense research. Three of the types of machine learning, supervised, unsupervised, and reinforcement learning, are used for different use cases, right? Most of the times in business, you're going to be using supervised learning. Reinforcement learning is very less used in real business. It's mostly used in game development, defense, and space research. And because it's very expensive, reinforcement learning is time. It is very time taking. The algorithm takes a lot of time to learn from the data, and also it is computationally very expensive. Compared to that, unsupervised learning is more of pattern recognition. Supervised learning is predictions. There's a question: after machine trained, will it store some rules uh, for the successful attempts? That will happen in supervised learning, Samyukta, not in unsupervised learning. Can we use supervised learning to predict next move to particular player? Yeah, that could be done, and that's more not exactly supervised. That's reinforcement learning. Based on the current move, you predict the next move, right? So that's reinforcement learning, and it works, and that's done. The performance in the next match for a particular player is already done using reinforcement learning. Well, so that was about the three types of ML algorithms: supervised, unsupervised, and reinforcement learning. Right. So I hope we're good so far with this idea. Right. Next, we're going to quickly talk about uh, one of the set of problems that we get in supervised. That means if we further categorize supervised, what are the types of problem that we get? Right. What are the types of problems that we get in supervised learning that we're going to learn? So there are two types of problems in supervised learning: classification, regression. And after this topic, next two slide, we'll move to understand one of the algorithm in real, right? And we'll be able to understand how exactly machine learning works out, right? So we'll be able to understand the idea of one of the algorithm called linear regression, right? So, well, here we are talking about the types of problems that we get in supervised learning, which is classification and regression, are the two types of problem that you get in supervised learning. Right. So what exactly is classification and what exactly is regression? Let's understand that. As we know that supervised learning is more about making predictions, right? Whenever you make prediction, that's where you talk about supervised learning algorithms, right? And into that event, there are two segments, classification and regression. So a supervised learning problem could be either a classification problem or a supervised learning problem could be regression problem. So the reason we are learning this because there are different algorithms for classification and different algorithms for regression, right? So we are trying to understand what exactly is classification and what exactly is regression, right? So whenever it comes to prediction, right? Whenever it comes to prediction and we know all possible answers, that's what we call as classification. For example, let's say that for a particular problem, I want to predict whether customer will leave the bank or customer will not leave the bank, or customer is going to buy the product or customer is not going to buy the product. We trained the model. For any new customer, the model is going to make prediction. For any new customer, after training the model, for any new customer, it is going to make prediction. Now the prediction answer would be what? Either yes or no, 0 or 1. You can say customer will leave or will not leave. So you can say for any customer, I know all possible answers, right? I just want to know whether this customer will leave the bank or will not leave the bank from the model. Let's say that if we are classifying the articles into politics, technology, and sports, right? So we know that we have three possible answers. Every article could be either politics article or sports article or technology article, right? So that's also classification. Whenever you know all possible outcomes, or we can say that we have discrete set of possible outcomes, we call the problem as classification problem, right? And so that's the idea. Other examples could be whether we want to predict whether the flight will be delayed or not delayed. So for a new flight, the possible outcome could be 0 or 1, yes delayed, no delayed. If we want to predict whether the email should be primary or social or updates or promotion, right? Like the way we get categories in Gmail, right? So we want to predict for any email. So we know that there are four possible answers, either primary or social or updates or promotions. Four possible answers for every email, right? So that's also classification problem. So in any case, if you know all possible outcomes, right, that's a classification problem, right? In mathematics, we call that, we say that we have discrete set of possible outcomes. We have discrete set of possible answers for any particular problem. Contrary to that, regression is more about when you do not know all possible outcomes. For example, if I have to make a prediction about stock prices of Tata Steel tomorrow, right? What will be stock price of Tata Steel tomorrow? So I can't say that, well, answer would be either 5,000, 4,000, or 6,000. It could be any numerical. The actual prediction could be any numerical value between a specific range. Like it could be 4,544.66. It could be 5,066.7788. It could be any numerical value. In case of stock prediction, you can't say that, well, the output will be either 5,000 or 6,000 or 6,500, or these are the four possible outcomes, or these are the eight possible outcomes. That's something you can't say, right? So that's the idea of regression, where the possible outcomes cannot be uh, counted, right? It could be any numerical value in a continuous range. That's what we call as regression problem, right? So these are the two types of problem we get in supervised learning: classification or regression. Okay, for example, if I have to predict whether the flight will be delayed or not delayed, I can say I have two possible outcomes, yes or no. So classification. But if I have to predict flight will be delayed with how many seconds, now when it comes to how many seconds, we don't have any possible answers. It could be 5, 6, 7, 8, 9, 20, 30, 40, 50, 100, 200 seconds as well. We can't have a 5 or 6 or 7 or 8 answers or 10 answers or a countable set of answers to say that flight will be delayed by these many seconds or not. Right, so that's a regression problem then. Right, so this idea of classification versus regression. All right, so let me ask you a question. Let's say if we have to predict based on the air pressure in the uh, air pressure in the tire of a car, if you have to predict for how many kilometers the car will be able to go, so will it be a classification problem or regression problem based on the observed tire pressure and the fuel available in the car? If we have to make a prediction that for how many kilometers the car will be able to run, so will that be a classification problem or it will be a regression problem? Right, we have to predict for how many kilometers the car will be able to run based on the uh, fuel and the air pressure in the tires and all. So it would be a regression problem because you're predicting the count. You can't say 5 kilometers or 10 kilometers or 5 6 kilometers or 7 kilometers. It could be any numerical value like 7.5 kilometers, 7.2 kilometers, like that. Okay, uh, other than that, let's say that if I have to recognize the digit on the number plate of vehicle, on the number plate of vehicle I can have digits like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 10 possible digits available on the number plate. So on a given number plate, if I have to recognize the digit, whether it is 0 or it is 1 or it is 2 or it is 3 or 4 or 5 or 6 or 7 or 8 or 9, these are 10 possible digits on any number plate. So if I have to recognize that using image processing or any other approach, will that be a classification problem or regression problem? Right, so if I have to recognize the digits on the number plate, right, and the possible outcomes are what? The digit on the number plate could be either 0 or 1 or 2 or 3 or 5 or 6 or 7 or 9, 8 or 9. So there are 12 possible outcomes. We can say it's a classification problem, right? Are you good with that? Right, in case you have any challenge with audio or maybe the screen, I would request you to rejoin the session. Okay, in case you have any challenge with that. So it's a classification problem. I hope all of you agree on that. Right, there's a question from Kusum. There is a question that classification of articles into politics, sports, or tech is an example of clustering, right? We group it based on similar patterns, so it comes under unsupervised learning also? No. So Kusuma, it doesn't come under unsupervised learning because when it comes to clustering, you don't know the groups in which you want to group them, right? You don't know the name of groups. In classification, you know the name of groups. That's the difference between classification and clustering. Clustering comes under unsupervised, classification comes under supervised. But in case of classification, you are categorizing them into known groups, right? That means the name and the count of the groups is already known. But in case of clustering, the name or the speciality of the groups are not known earlier. So you can say classification, you know the objective, what you want to achieve, or you know what in which groups you want to group them, right? In clustering, you don't know that. I hope that answers your question, Kusuma. Yes, Soumya, much more like that, right? And there's a question how number plot example is classification. So Akshat, we don't, you know, the algorithm is not going to calculate number plate. It is going to recognize the digits on number plate. So on a number plate, there are 4 digits, right? So every digit could be either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9, right? For any digit, the number of possible predictions are 10, right? Any digit could be either out of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It could be any possible number out of that, right? But there are only 10 possible outcomes, Akshat. That's the reason it is a classification problem. Any digit, it could be a either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. So it is a 10 class classification problem. It cannot be 5.4, 5.6 or 4.3 like that. It is only these 10 possible outcomes. If that answers the question. right? If I have to predict, you might be using Ola or Uber, right? In Ola or Uber, when you book a cab, right, the app also predicts the fare of the ride. Predicting fare of the ride, is it a classification problem or regression problem? Is that the machine learning algorithm used is doing solving classification problem, or that ML algorithm is? That's an ML algorithm which predicts the fare of the ride, right? So is that algorithm regression or classification? In Ola or Uber, when you use the app to predict the fare of the ride, right? So when you use the app, it when you mention the starting point and ending point, it predicts the fare, right? So is that a regression or classification? So that's a regression, because predicting fare is a regression. Any possible outcome could be there. That sort of that's used in both regression classification. All right, I hope I'm properly audible. Right. So in order to better understand this, Adityan, I am audible to others. I would request you to check it your end. Maybe there could be a challenge at your end, because to me the signals are strong, and I think it's like I'm audible to other participants as well. So here, in order to better understand this regression classification, again, Anshu and Rajat, we're gonna see the idea of regression classification in more other with other approach. So this will help you out to understand it much better, right? So if we talk about type of credit score, geography, gender, age, tenure, balance, right? These are all variables, right? So this is the other approach to understand or being able to differentiate between classification and regression. Will help you out much better to make the concepts more clear, right? So there are two types of variables every time: continuous variable and categorical variable. For example, in credit score, this customer has a credit score of 619 and this customer has a credit score of 608. So I hope you would agree if I say that first customer has 11 higher credit score compared to second customer, right? First customer has 11 higher credit score compared to second customer. Second customer has 106 higher credit score compared to third customer. Third customer has somewhere around X or 100 or somewhere around 197 lower credit score compared to fourth customer. So multiple values of credit score do have a mathematical relationship. They are mathematically higher or lower than each other, right? In case of credit score, multiple values of credit score have a relationship. They are mathematically higher or lower than each other, right? Such variables in which multiple values are higher or mathematically higher or lower than each other, or such variables in which values have mathematical relationship, are called as continuous variables, right? Such variables are called as continuous variables. So credit score is a continuous variables because multiple values do have a mathematical relationship. Compared to that, if I switch to geography, the current uh, customer has France, Spain, Germany. So can I say France is 10 or 20 higher than Germany, or Germany is 10 or 5 higher than Spain? Or do the France, Germany, Spain have a mathematical relationship? Is that in this feature multiple values have mathematical relationship, right? So we can say that, well, France, Germany, Spain, or multiple values of geographies do not have any mathematical relationship. They are not mathematically higher or lower than each other. They are just name of countries. This kind of variables are called as categorical variables, right? So there are two types of variables: continuous and categorical. Gender, is that a categorical or continuous? Gender would be a categorical variable or it would be a continuous variable. It will be a categorical variable or it would be a continuous variable. So I hope all of you would agree that gender seems to be a categorical variable, right? Gender seems to be a categorical variable, right? And similarly, if we talk about age 42, 41, 39, 43, is that the multiple values are mathematical higher or lower than each other? Can we say 42 is 3 higher than 39, or 39 is 4 lower than 43? right? So is that age a continuous variable or categorical variable? It's a continuous variable, right? So I hope all of you would agree that age seems to be a continuous variable, right? And tenure, 2 years, customer is associated with the bank from 2 years, 1 year, 8 years, 7 years, 6 years, 10 years, 5 years, 7 years. Will this be a continuous or categorical? This is a continuous variable. Tenure is also continuous variable. Among grading system is a categorical, right? So here continuous variable. Balance, the amount of balance in the customer's bank account, is that a continuous variable or categorical variable? So balance seems to be continuous. Number products, right? The one, I have one product or three product or five product from the bank, right? Is that a continuous variable or categorical variable? Is that the multiple values have mathematical relationship or not? It's a continuous variable, right? Now, customer has credit card, customer doesn't have credit card. So there are two things. One, customer has credit card, customer doesn't have. Yes, credit card, no credit card. Yes, credit card, no credit card. Yes, credit card, no credit card. So will that be a categorical continuous? Yes, credit card, no credit card. Yes, credit card, no credit card. Right. So those people who have credit card, they don't have any mathematical relationship with those who do not have. Right. So can we say that this is a categorical variable? Yes, credit card, no credit card. It's a binary value, right? 0, 1, 0, 1. That means yes, credit card, no credit card. Yes, credit card, no credit card. So that's a category. There are two categories: yes, credit card or no credit card. For is active member, not active member. The customer who are active member, some of them are not active member. So categorical or continuous? Yes, active member, no active member, like that. Will that be a categorical variable or continuous? So has credit card was a categorical variable. Similarly, is active member, no active member, yes active member, no active member is a categorical feature. Salary. Salary is continuous or categorical? I hope all of you would agree that salary is a continuous feature, right? Finally, exited. Is it the categorical or continuous? Yes, left the bank, no left the bank. Yes, left the bank, no left the bank. Exited, not exited. Left the bank, did not leave the bank. Left the bank, did not leave the bank. Is that a categorical feature or continuous feature? Is that a categorical feature or continuous feature? Right? Exited, not exited, exited, not exited, exited, not exited. So that's a categorical feature, right? Now in this data set, in this problem, our objective is to predict which customer will leave the bank. So which column is a label? Which column is the label column? In this data set, our objective is to build a model to predict whether customer will leave the bank or not. So which column is the label column? Which column is the target or label? Exited is the label. So whenever your label or the column which you want to predict is a categorical, the problem is a classification problem. Whenever your label is a continuous, the problem is a regression problem. Whenever the label that you're trying to predict, what we are trying to predict, whether customer will leave or will not leave. Whenever the label is a categorical feature, it's a classification problem. Whenever the label is a continuous feature, it's a regression problem. That's one of the thumb rule you can use to decide classification versus regression. So whenever you're trying to predict a categorical value, that means you know possible outcomes. In this case, exited has only two possible outcomes, 0 or 1, 0 or 1. So it's a classification. Other way to say that is, whenever my label is a categorical feature, it's a classification problem. Whenever label is a continuous feature, it is a regression problem. In the same scenario, if we talk about predicting salary, right? So if it is about predicting salary, it will become a regression problem because the label is a continuous feature. And for salary, you can have any possible numerical value, right? So one of the way to understand classification versus regression is that whenever you want to predict a categorical value, it's a classification problem. Whenever you want to predict a continuous value, it's a regression problem, right? So that's a thumb rule to sort of uh, decide classification versus regression. So Rajat, Anju, I hope this gives you a little more clarity about understanding regression classification. Everyone, I hope you're good with that logic so far. Any question? Right. So let's go further. So this was about two types of problems in supervised learning. Now let's talk about unsupervised learning. In unsupervised learning, there are four types of problem actually, but here we're going to talk about two of them: clustering and anomaly detection. Before that, there is a question: does a machine performs reinforcement learning based on the previous? No, it doesn't perform based on supervised or unsupervised learning. There's a completely different approach, Samyukta, for reinforcement. Can there be more than one category? Yeah, there can be more than two categories, three categories, five categories. Like vehicle number plate digit recognition has 10 categories. So it is a 10 class classification problem. I can have 20 types of emails to be classified. So I can also have 20 class classification problem. Okay, so now we can talk about we're going to talk about the idea of problems in unsupervised learning. So unsupervised learning is about pattern recognition, recognizing pattern in the data. The type of problems are four, but here we can talk about two of them. And next slide, we can talk about one of them. So clustering is one of the unsupervised learning problem. We have already seen the idea of clustering, right? Clustering is about categorization of objects or observations based on the similarity into the features, right? So like the news articles, categorization of news articles by Google News is an example of clustering. Other than that, clustering is widely used in a variety of domain. For example, you can see here, let's say this is age of customers and this is salary, right? X-axis is age and Y-axis is salary, right? So we can say that here we have set of people who are into red cluster, right? These are the people who have similarity in terms of they all have similarity as lower age and lower value of salary, right? They all have low value of age and low value of salary, right? These are people like me who are into this particular group, low age and low salary. And then we have the other group of people who are into this, and these are the people, right, who are having higher age and lower salary, right? And these are the people who are like my wife and they are having higher age and higher salary. Well, she's going to taunt me on this. Okay, so this is where you can say that we have three groups of customers who are having some similarity into the age and salary, right? And here we have red cluster where the customers do have similarity in terms of age and salary. They all have lower age and lower salary. These people have higher age and lower salary. These people have higher age and higher salary. Clustering is about grouping of observation based on the similarity into the features, similarity into their properties. That's what we call it clustering. For example, the Google News example, clustering the news articles is also an example of clustering. Other example could be clustering stock prices. So by clustering stock prices, we can get the idea that which of the stocks move together, right? So if I cluster stock prices, I would be able to observe the stock prices of steel companies and the automobile companies move together because steel is used as raw product in automobile. So if the automobile is going to go high, steel prices stocks are also going to go high, right? The stock prices of cement industry and oil and gas go down or go high together because cement uses transportation and transportation uses oil. So clustering can help us identify that which of the stocks move upwards together, which of the stocks go downwards together. So that if one of the stock is going high, I can also understand that which of the stocks are more likely to go high and I can invest into them. So clustering is also used for stock segmentation, right? And other than that, there are a bunch of examples of clustering, right? A couple of examples I can show you could be, let's say if I run some of the codes now, this is not the practice exercise, but yep, just to show you some examples, I'm going to show maybe one or two examples out here. Okay, let me give a try on this. Here you are. Let's say that maybe I can sort of well, you might be using all Google Maps, right? And when you use Google Map, it's much more like you get to see a very well segmented map, right? But the actual satellite image doesn't look like that. So Google uses clustering to convert the actual satellite image into the Google map. Oh, I was kind of so let's say that this is one of the satellite image. This is how actual satellite image looks like. In this image, there are multiple colors. You can say there are multiple colors of blue, which are representing the sea area, or the dark green, light green, things like that. Colors are there. This is how actual satellite map looks like. But when we see Google Map, we see a very well segmented map in which there are hardly 3 to 4 colors which are used to represent the land area, or the green area, or the water area. Right? It's a very well segmented and you can say sort of managed map. But they don't put humans to do this because the world is so big, they can't keep humans to manage it, get the each and every part of the world. So that's where they use machine learning to do the job, right? So you can look at this map and there are multiple colors in this. We can apply clustering on this with number of clusters as 4, right? So what will happen is those colors which are very closer to each other will be clustered as single color, right? So let me apply clustering and run the result over here. So I'm applying clustering with k equal to 4. And this is an example of one of the algorithm called k-means clustering. Right, here we go. And now the same map is now visible with only 4 colors. So there are only 4 colors available, 4 types of colors you can say available in this map, right? Only this dark blue to show the deep water, light blue all everywhere to show the shallow water, yellow color to show the land area, and only one green color, like one type of green color. There are no shades of green color to show the particularly green area, right? So this is where segmented map looks like after applying clustering on this. There are only 4 types of color. The other colors are clustered into the same, right? Now a little bit more fine tuning will make it look like actual Google map. So this is how Google does the mapping and generates Google map out of the satellite images. They use clustering into that. All right, so that's sort of idea about clustering. One more example from, as we had a couple of participants from bioinformatics and all, I can give you is from bioinformatics, and that could be, let's say, uh, on MRI scan. Just a moment, let me connect charge on my laptop, otherwise it's going to betray me out. Okay, so other example I can give you is could be when you talk about MRI images, MRI scans. MRI scans are more of when it comes to them, right? If I can show you one example out of it, let me give a try on that. Okay, well, I'm not able to find it, looks like. I had an example of brain tumor. It looks like I'm not able to find it out. And okay, so I can show you other example out there, right? So the other way to get that out is so when it comes to MRI scan, when it comes to MRI scan, in MRI scan there are hundreds of images which are part of MRI scan. Every MRI scan is a 3D image, and when we see MRI scan, it's like doctors are going to simply analyze that and going to look at whether there is a tumor or not, right? So in order to make that work easy, bioinformatic devices also use clustering, right? So what they do is, they in the MRI scan there are always 3 types of color for a normal brain image: the background color, color of the skull, and the blood color. These are 3 types of colors in normal MRI scan. Now what they do is they apply clustering with 4 clusters. In the first cluster, they're going to get the colors, or the color which is background image, and the background, which is here you can say that blue. And the second cluster, they're going to get maybe the skull or blood, which is, let's say, this blue or yellow. If they get anything in the fourth cluster, that means that's a tumor. So here you can see that green is fourth cluster, which is actually a tumor. So to detect tumor out of the brain image, brain MRI scan, they use clustering. K means clustering, and they are simply other approach of clustering, C means clustering, like that, right? So clustering simply categorizes the brain image into multiple groups, and simply if they get anything in the fourth group, that means there is a tumor. If they don't get anything in the fourth group, that means there is no tumor. That's a machine learning way of identifying tumor in the brain image, brain MRI scan. So well, these are sort of variety of examples of clustering where clustering is widely used, and it's one of the very widely used unsupervised learning model. Okay. So clustering is nothing but categorization of observations based on the similarity into the features. Well, next set of problem we can talk about is anomaly detection. Anomaly detection is about detecting anomalous observation or detecting any suspicious observation, right? So credit card fraud detection is one of the very good example of anomaly detection. So let's say that if every day I make a transaction of 5,000, 5,000, 5,500, 4,000, 5,000, 6,000, 5,000, 6,000, and someday if I make a transaction of 45,000, which is a very anomalous and suspicious behavior based on my past credit card transaction patterns. So the algorithm is going to block that. So what the algorithm does in anomaly detection is it detects a single pattern, right? It detects a single pattern. If anything is out of that pattern, very out of that pattern, that's going to be observed as anomaly, and it's going to be blocked out. So anomaly detection algorithm outputs one of the very good example of anomaly detection could be, I hope I'm audible to all of you, right? So we're talking about anomaly detection, where anomaly detection algorithm recognize any suspicious pattern based on the past pattern, or you can say past behavior, right? So if I every day do transaction of 5,000, 6,000, 5,000, 6,000, 5,400, 6,500, 7,000, someday if I make a transaction of 45,000 or 50,000 from my credit card, that transaction will be blocked because it's an anomalous behavior based on my recent credit card transactions, or the behavior of my recent credit card transactions. So that's where it's an anomalous behavior and it will be blocked. So anomaly detection algorithm recognize any suspicious behavior and they give that as an output that, well, this behavior looks like a suspicious one. One of the very good example could be your Gmail security. Every day if I access my Gmail from my laptop, I don't get alert out of it. But someday if I access my Gmail from my wife's laptop, Gmail says that your email is accessed from a suspicious location or maybe suspicious person. Now that's where I have a problem. And so that's an example of detecting anomaly, that every day I access my Gmail and someday my wife is accessing my Gmail from her laptop, right? So the Gmail algorithm simply checks the machine from which the login is made, and whenever there's a new login from a different device, that's an anomaly in the regular pattern, right? So that's an example of anomaly detection. And someday, let's say that every day I access my Gmail from India, or let's say Mumbai, and someday if I travel out to Kolkata, I'm getting an alert that, well, your email is accessed from a suspicious uh, location. That's also an example of anomaly detection, right? So I hope you're good with that. So I hope my screen is visible and my voice is audible to all of you. Am I properly audible to all? Okay, thank you for the confirmation. Right. So that was an example of anomaly detection. So anomaly detection is also a type of problem which falls under unsupervised learning. Yeah. There was maybe a slight issue. So I hope now we are good. Right. So we're talking about anomaly detection, right? And uh, that's about observing anomalous or suspicious behavior from the data. Okay. Thank you, Fawad. And let's go next and talk about one more type of problem under unsupervised learning, which is recommendation system. Recommendation system is also a type of problem. There's one more called dimensionality reduction, which we're not going to discuss now, but yep, that's also there. So recommendation system is more about recommending the user the product based on the observed pattern, right? The pattern could be matched based on the type of product being purchased. So we call it item to item similarity matching. And that's also called as content-based filtering. And the other could be collaborative filtering, whereas we talk about user to user similarity matching. which we call as collaborative filtering, right? For example, if I go to Amazon, if I buy a washing machine, so if I'm being predicted while buying washing machine, if I'm being recommended to buy a refrigerator as well, that's based on content based filtering, because washing machine and refrigerator fall under electronics product. So if I'm buying one electronics product, I'll be recommended with other electronics product, which is what you call content based filtering. That means the similarity match is being done based on the item I'm purchasing right now. If I'm watching a romantic movie, I'm recommended with more romantic movies. That's an content based filtering or content based recommendation, right? But there could be other approach, that's user based recommendation, that's collaborative filtering. That means, let's say that if I'm watching a movie called Now You See Me, and so there might be a lot of people in this world who might have seen this movie Now You See Me, right? So content based filtering, sorry, collaborative filtering actually does a user profiling. That means it categorizes us in that category of people who have seen this movie. Let's say that I have seen already Harry Potter and the Independence Day, and now I'm watching Now You See Me. That means I have seen these three movies, right? I like these three movies. There might be set of users on Netflix who might have seen same three movies. That means I virtually belong to those categories of people. Then the algorithm will look in that world. That means in the group of such people, which of the other movie is most popular one, which I have not seen, right? So that's what it is going to identify, and based on that, it's going to recommend me, well, that looks like this is the movie that you may want to see, right? So it is going to look at what other people who are like me are doing and that I'm not doing, right? Which other movie is most popular among the people who are having likes like me, and it's going to recommend me that movie, right? So that's more of collaborative filtering, right? So that's the idea so far about it. I hope you're good with that so far. Let me know if you have any question. Okay, so that's the idea so far about recommendation system. So these are the type of problem that we have seen so far, and you know, this set of understanding of theoretical logic we have made. Now we're gonna move towards understanding one machine learning algorithms. We have been so far talking about a lot about machine learning, but the question might be, well, logically this seems good, but technically how does it works out, right? How do you actually make the algorithm learn, and how is it possible to make an algorithm learn from data, right? So that understanding we're going to see now with one of the example, one of the very basic example called linear regression, right? And with that, we'll be then mathematically verifying that whatever the algorithm we're going to see the maths behind that, and we're going to program that maths as well, right? And then we're going to work on one of the real use case on the same, using the same algorithm, right? So that's sort of idea, right? And yep, I hope you're good so far, right? So yeah, now we're going to see the implementation, sort of mathematics and mathematics behind the algorithm, and uh, the programming implementation of the same. Okay, so before we move ahead, let's take a short 15 minutes break, and because that concept is going to be a continuous one, we're going to be taking more around let's say 2 hours, to finish that complete implementation part. So let's take a short break, and then we can further resume, right? So we'll take a short break of around 15 minutes, not so much heavy as yesterday of 40. We'll take a short one for 15 minutes. So we're on 15 minutes break, and after that we'll resume further. So let me write it out here. I'm muting myself. See you all in 15 minutes. All right, so I hope all of you back, and we're going to continue further. All right, so far we have been sort of looking at the idea of yep. So yeah, so far we have been looking at the idea of uh, introduction to artificial intelligence, machine learning, deep learning, and so we're going to now be quickly checking out the idea of one of the ML algorithm, which is linear regression, and understand the maths behind this algorithm, the logic of this algorithm, how does it works out actually, and how do we implement it, how do we use it in in real world use case, and so that sort of stuff we're gonna be sort of seeing up here, right? So let's get into that. Okay, so we're going to be looking at the idea of linear regression with context of one of the application, right? One general real world use case, and so yeah, let's get into that. Let's say that well, before going ahead with that, I'm going to be sort of, well, I think many of you are uh, good with mathematics. I mean, you might like mathematics, I think. I hope so. I mean, I suppose you like mathematics. So considering that, we're going to be seeing a little of maths, but don't get scared with that, right? We're going to be seeing a lot of logic behind that. And when it comes to mathematics behind algorithms, in real world, we don't need to program that mathematics. We have ready-made functions available, which does the mathematics completely for us. So when it comes to integration, we'll be looking at both the approach. Right. So let's get started. Let's say that if we have to build a model to predict housing prices in a particular area, right, the price of flats in an area. All right, before that, let's say that I am living in Bangalore, and I know two people in Bangalore. One of them is my friend who is into real estate business from last 6 months, right? So I'm living in Bangalore, and I know two people in Bangalore. One of them is my friend who is in real estate business from last 6 months. And so one of them is my friend, and I hope my screen is also visible to you. It should be visible, and let me kind of unshare and share it back. Okay, check it now. So one of them is my friend who is into real estate business from last 6 months, and another is my uncle who is into real estate business from last 15 years. So my uncle is kind of into business of buying and selling flats from last 15 years, and my friend is into that business from last 6 months. And I want to buy a flat. If I go to both of them to ask for a suggestion to get the right price of the flat, who is going to be able to get me or give me the right suggestion or the most appropriate price of the flat? My uncle or my friend, right? Who is going to be able to give me the right price of the flat? Uh, my uncle or my friend? So most probably you're going to say that, well, it looks like your uncle is going to be, as he's having 15 years experience in the business compared to your friend who is having just 6 years of experience. In the 6 months of experience, he might have bought and sold maybe 2 or 3 flats, right? So your uncle seems to be more experienced. In 15 years, you might have bought and sold a variety of flats and plots, right? So that's where he seems to be more experienced. When you say experienced, that means he has learned more patterns or consumed more data, that whenever this is the area, or this is the location, or this is the size, 2 BHK, 3 BHK, 1 BHK, one bedroom, one stuff, and with attached garden, without garden, things like that, this should be the price. He would have gained such multiple experiences while buying and selling flats in his 15 years experience compared to my friend would have done in last 6 months. My uncle would have bought and sold a variety of properties, and that's where he has learned more of pattern. With every buy and selling of property, he has learned a pattern that, well, if there's a situation, this should be the price. There's a situation, this should be the price. That's where my uncle has consumed more data and he's more intelligent. Compared to my uncle, my friend who has just bought and sold maybe countable one or two flats and plots. He is less experienced. He has bought and sold less flats and plots. He has consumed less data. He is less intelligent. If my friend also keeps on buying and selling more and more flats and plots, he'll become more intelligent, much more like my uncle. That means if my friend also keeps on buying, consuming more data, he'll become more intelligent. Data is key to intelligence, right? More the data, more the intelligence. The volume of data is key to intelligence. Quality and quantitative data is going to improve the performance of algorithm. So the way my uncle has learned from the data and he is more intelligent and my friend is less intelligent, the same way we make the machine learning algorithm learn from data. And the logic is more and more data that you feed, more intelligent the algorithm becomes. The volume of data is high, the performance of algorithm is also going to be high. Right. So let's understand that the similar scenario with the context of housing prices prediction or predicting the flat prices. Now, when it comes to predicting the flat prices, there might be a number of variables which may impact it. For example, area in square feet will impact it, which will heavily impact it. Other parameters may be the number of bedrooms, number of washrooms, the distance from city center, distance from airport, school, hospital, distance from gardens, distance from employment houses, the traffic in the area, the accessibilities, the availabilities of amenities in the apartment. There can be multiple features which may impact the price of the flat. For simplicity, let's say that here we consider only one, which is area of the flat. So area of the flat is input, and let's say that we denote it by x. And price of the flat is output, and we denote it by y. So we have x and y. So y is, you can say, the label, and this is the input feature. Right. So this is the data that we have, right? X as a feature. There can be multiple features. As we discussed, that for the simplicity's sake, we are considering only one feature, which is area of the flat. So let's say it's my friend who has bought and sold two flats, 1200 square feet, 20 lakh, 1800 square feet, 42 lakh. Don't ask the address of my flat. These are just dummy prices, right? So my friend has bought and sold these two flats. And now if I go to my friend and say that, well, man, tell me what should be the price for this particular flat? I'm going to ask him that what should be the price of 3200. So, well, if we try to represent the current knowledge of my friend, right? If we try to represent the current knowledge of my friend, the current information gained by my friend, so we can say that these 2 points can be represented like this: 1200 square feet, 20 lakh over here, 1800 square feet, 42 lakh over here. And we have to make a prediction for 3200 square feet over here. For this particular price, we have to make a prediction for this particular area, what is the price, right? So if I set of, if I have to represent maybe a geometry which can represent the pattern contained by these 2 points. So what kind of geometry can I draw which can, pass through these 2 points? So I hope you would agree that, well, you can draw a line. So I hope all of you would agree that, well, you can draw a straight line and that can pass through these 2 points and can help you approximate the price for 3200. So I can draw a line here. And my drawing is a little bad. I used to get D grade in school. So just bear with me if the line doesn't look very straight. Okay, so here we go. And so this is the line which passes through the 2 points. And here we can see that, well, for this particular line, if we have to predict for 3200, my friend would predict something like this. So he's going to say that, well, this is the prediction. This is the prediction according to my friend's knowledge, but we know the actual price is very different, and the actual price is here somewhere 44 lakh, right, which is different than that, right? So the prediction has somewhat error because my friend is very new guy and he has just bought and sold only 2 flats, right? Well, if we try to mathematically represent the idea of predictor here, so the predictor here is a straight line. What is the equation of straight line? The equation of straight line is mx plus c, where m is the slope and c is the intercept. Let's say that mx plus c is equal to y hat. Y hat here is representing predictor price. So what is x here? Area. Y, actual price, and y hat, predicted price, right? So let's say y hat equal to mx plus c is the equation of the line. That means this prediction can be represented as y hat, and whereas the actual value can be represented as y, right? Prediction is y hat. That means whatever the model predicts, the model is, or the predictor is here, the straight line, which is y hat equals mx plus c. That line is able to make a prediction for any given value of x, right? For x equal to 3200, it's going to make a prediction somewhere around, let's say, 81 lakh. But we know the actual value is 44 lakh, right? So here we got a specific prediction, and that prediction is not accurate, very having error into that. If I wish to calculate the error, or represent the error in the prediction, we can say that, well, error in the prediction can be represented by a equals y minus y hat. This is how we can represent error in the prediction. E equals y minus y hat. So E is the error in prediction, right? E is the error in prediction. All right, so this is where we can say that the difference between y and y hat is E, and uh, that's the error in prediction, and that's there with respect to this particular point. That's there with respect to this particular point. And we can also have error with respect to other points as well, right? For example, for 3825 lakh, there would be more error. The point is here. For 4262 lakh, maybe the point is here, and the error is also heavy. So there is error with respect to multiple points, right? Right, there is some error with respect to this, some error with respect to maybe this, some error with respect to this also the line has. Okay, now if I draw another line, everyone, if I draw another line here, let's say this line. So can I say that green line has, this new line, green line, has less average error compared to the blue line? The green line has less average error compared to the blue line. Can we say like that? I hope all of you agree. Let me know if you agree. You might say that, well, for the very first 2 points, it has slightly increased. Yes, I agree on that. But overall average error, if we say, the overall average error is lesser in the green line compared to the blue line, right? That means you can say the green line is more precise predictor compared to the blue line, or you can say more average accurate predictor compared to the blue line. The green line is much better predictor compared to the blue line. The performance of green line is high compared to the blue line, right? So, well, that means if I shift to the line from blue to green, the error E decreases. The overall error E decreases, right? So the equation of blue line is y hat equals mx plus c. This is the equation of blue line. What should we change in that? What should we change in that equation so as to shift from the blue line to green line? What should we change in that equation? Y hat equals mx plus c. Which parameter needs to be updated or slightly changed so as to shift from blue line to green line? By changing value of which variables or maybe the parameters, we can shift from blue to green. Changing from blue to green line, what will change in the equation? What will change in the equation so as to shift from blue line to green line? Well, so we can say that m, that is slope of the line, will change, and c, which is intercept, should also change. As we can see that blue line has intercept 0, whereas green line has somewhat value of intercept, right? So there's a question, how did you kind of added a new line, right? So we added a new line, just a normal, randomly picked up line, but yeah, it could have been calculated one, right? So here we can say that if I have to shift from blue line to a green line, or let's say that blue line to a slightly more accurate line, changing the values of m and c, right? Changing the values of m and c can bring us from blue to green. Let me know if you all agree. Changing the values of m and c in the current, changing the values of m and c to a specific value can bring us from blue to green. Let me know if you all agree on that, right? The blue line equation is, in case you have any doubt, any question, please feel free to put that here, right? So related to the current topic, please don't go out of the topic. So the green line is a new line, a randomly drawn line, right? There's a question, what is this green line? Well, let's say green line is a randomly drawn line, and imagination that, well, if I shift blue line to a certain position, I can decrease the error, right? So can we say that by changing the values of m and c in the blue line, we can shift from blue to green? Or can we say, if we forget green line, can we say by changing m and c, we can minimize the error or we can reduce the error? By changing m and c in a certain direction, can we reduce the error? If you even forget about green, by just imagining and understanding the green line, let's say green line seems to have lesser error compared to blue, and to shift from blue to green, you need to change values of m and c. So can we say by changing the values of m and c, can we minimize the error? Let me know if you all agree on that logic. By changing the values of m and c, can we minimize the error? Right. So error depends on m and c. Right. I hope all of you agree that by changing the values of m and c, we can minimize the error. But the data 42 lakh is out of the new line, right? Yeah, it's out of that. It's out of that, but it's very closer to that. It's very closer to that. So we say that average error is reduced, right? So by changing the values of m and c, we can say that we can minimize the error up to some extent, right? I hope all of you agree. By changing the values of m and c, we can minimize the error up to some extent. Yeah, we can also draw the other line which can show the error very lesser compared to the other two, right? So if we program this process, everyone, now this is very important. If we program this process that you feed the data, calculate error, change MNC to minimize error, feed the data again, calculate error, change MNC to minimize error, feed the data, calculate error, change MNC to minimize error, feed data, calculate error, and change MNC to minimize. If you program this process that recursively, we feed data to the model, calculate error, change MNC to minimize error, feed data, calculate error, change MNC to minimize error. In every iteration, we can make the algorithm more and more accurate, and that's how we can make the algorithm learn from data. Can we say like that? If we program this process, feed the data, calculate error, change MNC to minimize error, we can make the algorithm improve in every iteration, and that's how we can make the algorithm learn from data. Let me know if you agree on that, right? So if you program this process of feed, you feed the data, calculate error, change MNC to minimize error, feed data, calculate error, change MNC to minimize error. So if we program this process, in every iteration, the error will keep on decreasing. If the error is decreasing, the performance is improving, algorithms become more and more accurate. So can we say that algorithm is learning from data? Right, the line will get more and more near to the data points and it will get more and more accurate at some point of time. Let me know if you'll agree on the logic. Right, if we program this process of feed data, calculate error, and change MNC to minimize error, if we program this process in a loop, we can make the algorithm learn from data. We can make the line learn from data. The straight line y hat equal to mx plus c can start learning from data. Right, so over a period of time this will happen. You'll observe that over a period of time, in every iteration the line will become more and more accurate. In zeroth iteration, you see the line is here. This is the position of line in zeroth iteration. The line starts from zeroth iteration here, and in every iteration it is trying to become more accurate, and at the 850th iteration at this position of the line, we can say that line is more and more accurate. Right, and it is very closer to all the data points and it is having very less error. So the idea of machine learning is you program mathematically the process of feeding the data, calculating error, and change the parameters M and C to minimize the error. This algorithm is called as linear regression. And for one feature, it's univariate linear regression. Right. So, well, that's sort of idea about linear regression. Are we good with the logical understanding of linear regression? Right. Feed data, calculate error, change MNC to minimize error. Let me know any question you have on this particular logic. This logic is very important. Make sure that you all are clear with this. So there's a question, we changing value of MNC randomly so that there is a chance of maximizing the error, sir. Yeah, I mean, you see, we have to make sure that the change in values is done in specific direction. We cannot change them randomly, right? Because if we take the line in opposite direction, the errors will increase. So we have to make sure that the changing is happening in a specific direction. To do that, there is a mathematical approach. We'll see that later, right? But yes, the idea is that MNC has to be changed in a specific direction. Otherwise, errors may increase. So there is a mathematical approach to solve that problem as well, to be able to identify in which direction I should change the MNC. Okay, well, which we'll see that in next couple of slides. Right. So are we good with the logical idea of linear regression? How do we make algorithm learn from data? Or you want me to repeat again? Are we good so far? So I hope we're good so far. Good to go ahead. Okay. So let me have a quick repetition. In a quick go, let me repeat that for a couple of participants. And as a couple of participants have requested to repeat that, in a quick go, we'll see that, right? So the idea is, so let's say that we are talking about housing prices prediction. We have two features, X and Y. So X is the area and Y is the price, right? And we have to make prediction of price based on the area. There might be multiple features which might impact this. For simplicity, let's consider one. Let's say that we have a data of 2 points, 1200, 20 lakh square feet, 1800, 42 lakhs, for 1200 square feet, 20 lakh, 1800 square feet, 42 lakh. And we have to make prediction for 3200 square feet. If we represent these 2 points in the Cartesian plane, 1200, 20 lakh here, 1800, 42 lakh here, right? And we have made prediction for 3200. Right, so that's what we have to do. Now, let's say that if we have to make prediction for this, based on 2 points, if I have to develop a predictor, I can simply draw a single line, which could be like this. Right, I can draw a single line which may act as a predictor for these 2 points. I mean, based on these 2 points, it can act as a predictor. So I can say that based on this line, the price for 3200 is somewhere this. Right, the equation of straight line is y hat equal mx plus c. It is actually y equal mx plus c, but consider y hat represents the prediction. There is no other meaning of y hat, just a symbol. Right, x is area, y is actual price, and y hat is predicted price, right? So this is the equation of predictor. So this predictor is making a prediction for the 3200. So for 3200, it says that this is the value of y hat, but actually value of 3200, is this one y. So there's somewhat error in the prediction. We can say that error in prediction can be represented as E equals y minus y hat, right? This is error with respect to this data point. And there is also other error with respect to 3800, like this one, 3825 lakh, which is somewhere around here. For this data point, 4262 lakh, which is somewhere around, let's say, maybe here. So there is error with respect to all the data points, somewhat error with respect to all the data points, right? There would be error with respect to this as well, error with respect to this as well, like that. Now there's a red line. If I draw another line, which is, let's say, like this, right, which is like this, just imagine this one more line. If the line would have been at this position, can we say that this line, the line number black line, let's say, is having less average error compared to the red line? Good with that? Mukul and Rajat, are we good so far? This black line seems to have less average error compared to the blue line. Right, there's a question. We know the formula for linear regression, but how do we convert this problem into an algorithm to find all possible errors and answer? Yeah, so we're gonna reach out to that. We're gonna reach out to that. Don't worry. We can see the complete maths. Don't worry about that. Right. So well, this black line seems to have less average error compared to the blue line. Sorry, red line. Right. That's where you can say that black line seems to be a good predictor compared to red. The question could be, how do you shift from red to black? So the answer is that by changing the values of m and c in the equation, we can shift from red to black. So you can say that our error depends on m and c. That means by making some directional change in m and c, I can shift from red to black. That means by making some directional change in m and c, I can minimize the errors. Right. So if you program this whole process of feeding data, right, feeding data and calculate errors. Yeah, that's a dark blue. It's a dark blue actually. And um, feeding data, calculating error, change MNC to minimize error. If we can program this process iteratively, in every iteration the error is decreasing. So we can say that in every iteration, when the error is decreasing, the algorithm is improving, algorithm is learning. So we can say that every iteration algorithm is learning from data. If we can program this process of feeding data, calculating error, change MNC to minimize error, in every iteration we are making algorithm more and more accurate. That's how we are making algorithm learn from data, right? So that's the idea so far about linear regression. How do we make algorithm learn from data? M is a slope and C is intercept, right? M is a slope and C is intercept. Intercept is like, if I had to explain you about equation of line, give me a moment, I'll do that. And that, I hope we're good with the process idea so far, right? Okay, so this is sort of understanding of linear regression. We'll talk more about this, understand more detail into linear regression, program this mathematics, and also prove this as well, right? Let's get in further. Okay, so yeah, so answer to your question, Mr. Muthu, right? So let's say that we have three set of lines, right? So you can see here, the equation of all the lines is y hat equal to mx plus c. Here, c is the intercept. That means the distance from the positive y-axis on the positive x-axis. Distance from positive x-axis on the positive y-axis. So c here is 40. As the line is parallel to x-axis, m is 0. In this case, the line is crossing, x-axis at y equal to 0. So c is 0, and m is somewhere around 0.8. That based on some calculation. The calculation formula for m is, if this is x2 y2 and this is x1 y1. This is just for the sake of knowledge. If you don't like mathematics, just skip this. The formula for m is y2 minus y1 upon x2 minus x1. Rate of change of y with respect to rate of change of x. It's what we say slope is about. Here you can say that, well, the line is crossing x equal to 0 at y equal to 40, right? So x is equal to 0 at y equal to 40. So c is 40. Here you can say that x is 0 at y equal to 0. So c is 0. X is 0 at y equal to 40. So c is 40. Like that. That's a formula of c, which you call as intercept. Right. So m here is slope of the line and c is the intercept. Right. That's the idea. I hope that gives you some clarity about m and c. All right. So this was just to understand the idea of y hat equal to mx plus c. Like, again, coming back to machine learning, linear regression. So let's say that we can talk about certain scenario. Oh, well, whichever, I'm missing out something. Just a moment. Yeah, this is what. So here we are. A little more understanding we're gonna make here. We know that our equation, which is helping us to do prediction, is y hat equals mx plus c, and the error in prediction can be a is represented by y minus y hat. This is a formula for error. If we talk about two cases, case 1 and case 2, this is y and this is y hat. And let's say that this is y hat and this is y. Right here it is y hat, y hat. Or you can say this is also case 1. Both are case 1. So in which of the case error is positive, in which case error is negative? Based on the given value y and y hat, in which case error is positive, in which case error is negative? Right, the error formula is E equals y minus y hat. This line is making prediction for a given value. This is y and this is y hat. This is y hat and this is y. In which case the error in prediction, that means the value predicted by the line, if we compare that with the actual value, there is error, right? If the actual value of the price is 44 lakh, line predicts 40 lakhs, so there is error of 4 lakhs, right? So if we talk about error in prediction, in which case error is positive or in which case error is negative? In case 1 or case 2, error is positive or negative? The question is that based on the given formula, E equals y minus y hat, right? And given value of y and y hat, in which case you think that error is positive or error is negative? Can we say that in case 2 it is negative? Yeah. There's a question from Nikhil that can please repeat the reason for plotting the green line. So Nikhil, the idea is the green line is, let us say, a predictor, right? It's a predictor which is helping us to do prediction. The equation of green line is y hat equal to mx plus c. That is helping us to do prediction. Okay. So based on the prediction made by the green line for a given data points, which case error will be positive and which case error will be negative? So we have a standard predictor. We want to have ML algorithm. So we're talking about a trained ML algorithm in this situation. So for this ML model, y hat equal to mx plus c, in which case error is going to be positive, in which case error is going to be negative, right? So the answer is in case 2, it's going to be negative. In case 1, it's going to be positive, right? So whenever y is higher than y hat, error is positive. Whenever y is lower than y hat, error is negative, right? Are we good with that, Nikhil? I hope that answers your question. Let me know. Right. So I hope we're good so far, everyone. The idea of error is positive, negative. So the context is that sometimes error can be positive value and sometimes it can be negative value, right? Error can be in any direction. Error can be in positive direction as well, and it could be direction away from 0. That is means it could be a negative direction as well. So that's the reason we can't just sum all the errors. We can't add all the errors blindly, right? If we add all the errors blindly, uh, the sum of the errors might go closer to 0, right? And another point is, if the error is positive value, let's say 10, we have to decrease that to 0. If error is minus 20, we have to increase that value to 0. Minus 20 is very lower than 0, so we have to increase that to 0. But if it is plus 20, we have to decrease that to 0. So whenever error is positive, it has to be decreased Whenever error is positive, it has to be decreased to 0. Whenever error is negative, it has to be increased to 0. So in real world, the error can be dual directional. When the error can be dual directional, the optimization of error has to be also dual directional, right? Are we good with that logic? So that makes a very difficult job. First thing, that you can't add all the errors, and secondly, if the error is positive, it has to be decreased. If the error is negative, it has to be increased. To handle this problem, the problem of dual directional optimization, which is very difficult problem, and the problem that we can't add all the errors blindly, what we do is we take square of error. So as in some situations error could be positive, in some situations it could be negative value. So the better way to represent error could be take the square of error. So we can represent error as y minus y hat square. If I take square of error, it will always be a positive value. If I take square of error, it will always be a positive value. So by taking square of error, we can make it a permanent positive value. That's how we can convert it always into a minimization problem. The problem which was earlier, you have to minimize or maximize it, kind of that. Now you have to only minimize it. So by taking square of error, you can convert the dual directional problem into a single direction. Then we can take the sum of all the errors and divide by count. So we call it MSE, mean squared error. So the benefit of mean squared error is that by representing any error in MSE format, you convert that into only a minimization problem. So this can be called as error function E or cost function J. The error function can also be called as cost function J. So instead of now minimizing this E, minimizing this E, we'll be trying to minimize this E. Instead of making that e to 0, we can make this e to 0. That's where we have converted a dual directional problem into a single direction problem. And we have made the error is always a positive value. So we are converting into minimization problem. So this is standard representation of error, mean squared error. A lot of people also take a root mean squared error. A lot of people also take other forms of error as well. But this is one of the most popular forms of error, representing error. Right. So I 1 by n summation of I equal 1 to n y minus y hat square is the representation of error. I hope we're good with this part. A lot of old people also take it 1 by 2n. Well, that's just for the sake of making mathematics easy, right? So when these algorithms were developed, it was developed in 1970s and 80s. At that time, people who developed this, they did not have computers to solve the maths. They used to solve the maths handy. As there's a square term, right? If you take a derivative of it, 2 will to come into multiplication. 2 will come into multiplication. So by taking 1 by 2n, 2 will get cancelled. There's a question, why take 1 by n? So for what 1 by n makes it mean. Adding all of them and dividing by n is what mean. So 1 by n is for mean. So we say mean squared error. Right? We could also take sum of squared error, SSE. Right? But the standard representation is mean squared error, a very smaller value you have. So 1 by n is to make it a mean. Mean is what? Adding all the values and dividing by n, the count. So n here is count, the total number of data points, like area and price, area and price, area and price, like that. I hope that answers the question. This E formula is also to convert dual to single, or to make it error to be positive value. By making error positive value, Bhavishna, we are doing converting the dual directional optimization into single directional optimization problem, right? So it by making error positive, it's doing that job. So it's ultimately doing both the jobs, right? There's a question, why are we using 2n, right? So yeah, we don't need to use 2n actually. So the idea is that when these algorithms were developed in 1970s and 80s. At that time, there were no computers to solve this using computers. So people used to solve this using handy mathematics. As there is a square term, right? If I further have to take derivative, in further we'll have to take derivative of this. So what is the derivative of x square? The derivative of x square is 2x. 2 comes into multiplication. If I take 1 by 2, 2 will get cancelled and mathematics will become easy. So whenever the people who developed this, the scientists or the mathematicians who developed this in 1970s and 80s, for them to make the mathematics easy, they used to take 1 by 2. For us, it is not important. But as we can't change the algorithm developed by somebody else, for our convenience, a lot of authors and researchers still take it 1 by 2, right? So 1 by 2 is not having any technical significance. It was early taken so as to just make the mathematics more convenience. If I take further derivative, 2 will get cancelled. That was the only reason for taking 1 by 2, no other reason. I hope that answers the question, Rajat and Aka. There's a question, why we take mean of error, right? So that's a good question, Mukul, right? So you see, if we try to compare two things, sum versus mean, right? Which is better to represent a particular data point, right? Sum is good or mean is good, right? So the reason, and out of this answer is mean is good. The reason is because let us say that if I talk about, I have to represent the age of all the employees in my company, company A, company B, company C, age of all the employees in company A, company B, or company C, age of all the employees, if I have to represent that. If I represent by sum, now I don't know that how many employees are there in company ABC. According to the number of employees in company ABC, the sum will get heavily impacted and will not be the good representation of any data, right? If company A has a higher number of employees, company B has less, and company C has medium number of employees, the sum will get impacted according to the count, but mean will not get impacted according to the count. So whenever we represent any data point, and if we are not sure about the count of data, we should always represent the data using mean rather than using sum, right? If I, let's say that company A has 20 employees, company B has 5 employees. If I talk about what is the age of employees, if I just say sum, it looks like company A has very old age employees, but that's not actual case, right? So mean shows the more aggregated statistics compared to what sum shows. Sum can get heavily deviated because of the count. The mean doesn't get deviated because of the count. Does that answer your question, Mukul? Why should we take always mean of everything? Mean is one of the very good representative when it comes to representing any set of data point compared to sum. All right. So well, that's idea. Let's summarize the whole process. There's a question, why squared mean instead of mean? Well, Arka, because earlier we discussed that if we just talk about error, error can be sometimes positive value and sometimes it could be negative value, right? So in this case, error was negative. In this case, error was positive. So whenever error is positive and negative, you can't add them like this. You can't add them blindly, right? That's how error will, positive and negative will get cancelled and your error will come like seem to be 0, which is not actual case, right? So when you take square of error, it becomes always a positive value. Square of any value is always a positive value. So that's the reason to convert this dual directional error into single directional value, we always take square of error, right? So let's go ahead and summarize this whole process, everyone, right, to understand the logic. So if you try to summarize this, and this slide is going to be important, right? Don't get scared with mathematics. This is just to understand the logic, right? So let's say that if I want to be an accountant, I need to know addition subtraction. But in the job of accountant, I will not need to do addition and subtraction manually. I have a calculator to do that. So the idea is that you need to know the concept, but well, you might need not to code the mathematics in linear algebra as it is in production or in your real job. That's where we have functions, Python packages to do that job, right? So don't get scared with the mathematics, right? This is just to understand the concept. Equation of regression model is y hat equal mx plus c. The parameters which we need to optimize in this case, that parameters which needs to be changed are m and c. The cost function is j equals 1 by 2n summation of I equals 1 to n y minus y hat square. And the goal is to minimize j by changing values of m and c, right? So if we have one feature, the equation is y hat equal to mx plus c. In case I would be having multiple features, the same equation will look like what? Uh, you can say it will look like y hat equals m1x1 plus m2x2 plus m3x3 plus c, right? The same equation will look like that if we have multiple features, right? So this is sort of nutshell what we have discussed so far, right? We have a regression equation y hat equal to mx plus c, which is going to help us do prediction. And the accuracy of this equation depends on the right values of m and c. As better values of m and c we have, that much better equation, or you can say the predictor we have, right? The cost function, that means the error in the prediction, can be represented by j equals 1 by 2n summation of I equals 1 to n y minus y hat square. And the goal is to minimize j by changing the values of m and c. I hope we're good so far here, right? So this is sort of basic maths. There's something more left, right? So at this point, we are good with the idea that, well, I have a predictor y hat equal to mx plus c. I can feed data to that, get the error j, and I want to minimize j by changing m and c. If I can do that, I can make the algorithm learn from data, right? If we can automate this process, we can make the algorithm learn from data. Yeah, so we'll talk about that. Here we are not taking Mukul. We are talking about that why we need to take. We are coming to that point. All right. So the point is that, well, if we can automate this process, that, well, we feed data to regression equation and calculate the cost function j, which is error function, and minimize j by changing value of m and c. We can make the algorithm learn from data. So, well, it looks good, but the problem is that we don't know how should we change the values of m and c. Should we increase the values of m and c, or should we decrease the values of m and c? Should we increase it by 5 or by 10 or by 20, or should we decrease it by 5 or 10 or 20? In what direction should we change the values of m and c so that j always minimizes or j always decreases? That's a problem we are stuck with, right? At this point, we know that we have to train the model, train the algorithm. To train the algorithm, we'll feed data to that. We'll feed data to y hat equal to mx plus c, get the cost function. For minimizing or reducing the cost function, we have to change values of m and c. What we don't know is how should we change values of m and c. Should we increase the values of m and c, or should we decrease the values of m and c? Should we you can say, should we increase it by 5 or 10 or 20, or should we decrease it by 5 or 10 or 20? That's something that we don't know. This is called as optimization problem. Right, this is something that we call as optimization problem. To solve this problem, what we do is, to solve this problem, now we're going to talking about something called, there are multiple mathematical techniques which can help us solve this problem, right? So one of them is, one of the very popular mathematical approach to solve such problem is gradient descent algorithm. Gradient descent algorithm can help us out to solve such problem, right? So gradient descent says that, well, I have a solution to your problem. I can help you out to optimize j by changing values of m and c. I can tell you how should you change your values of m and c, to minimize j. So gradient descent is the solution to our problem. What is our problem? We don't know that how should we change the values of m and c to minimize j. And gradient descent is the guy who says that, well, man, come to me and I have the solution. So it says that, well, I have the solution. I'm going to tell you out that how should you change your values of m and c so as to make sure your j is going to be minimizing out, right? So that's where we will reach out to gradient descent and see that what it says. Well, gradient descent says that, let's see the solution. So gradient descent says that if you want to minimize j, if you want to minimize J, which depends on M and C, then change M and C in this manner. Then change M and C in this manner. New value of M equal to old value of M minus learning rate into del J by del M. New value of C equal to old value of C minus learning rate into del J by del C. Don't get scared with mathematics. This is just a logical idea. And in practice, you don't have to program this. We have ready-made functions which have all the mathematics pre-programmed. We just have to understand the logic. So guidance says that, well, I have a solution to your problem. And it says that, well, it's like, you know, you change your values of MNC as new value of MNC equal old value of MNC minus LR. LR here stands for learning rate, right? So which is what we will discuss. What exactly is that? LR here stands for learning rate multiplied by del J by del M. Del J by del M is nothing but, you can say del J by del M is partial derivative of J with respect to M. And what it shows actually, the contribution of M in M in J is what it shows. That's what you want to minimize, right? So Granny says that, well, you change your values of M and C in this manner, right? And your J will definitely decrease, right? Your J will definitely decrease. That's what gradation guarantees us, right? So what is learning rate here? Learning rate is the rate at which algorithm learns from data, right? So it's like, you see, if I being a human, if I have to learn to sing a song, or maybe to write Python code, or to dance with my wife, in all these situations, the speed at which I can learn to do these jobs would be different, because the complexity of every problem is different. So for any algorithm, the speed at which the algorithm learns from data, that depends on the complexity of problem. As a developer, we have to decide the value of learning rate which matches with the complexity of problem, right? The speed at which algorithm can learn from data, right? So LR here is the learning rate. In this whole algorithm, we did not invented this algorithm. We did not invented and created this mathematics, but as a developer, it's my job to decide the value of learning rate. In every machine learning algorithm, you get similar mathematics, and you have to decide value of any of the hyperparameter. Here, that is learning rate, right? So the idea of learning rate is how fast algorithm learns from data, right? So the as fast we can learn from data, that depends on the complexity of problem. For example, the speed at which I can learn to ride a bike, I can learn to play music, or play a guitar or sing a song, that depends on the complexity of problem, or the speed at which I can learn to write a code in Python. That depends on this complexity of problem. So the idea is that learning rate here has to be decided by the developer based on the complexity of problem, and it can be any value between 0 to 1. It can be any value 0 to 1, excluding 0 and 1. So 0 0.1, 0 0.2, 0 0.5, 0 0.4, 0 0.001, any value between 0 to 1 is what the value of learning rate could be, right? So in this whole mathematics, my job to understand learning rate, to decide value of learning rate. So why it is important for understanding why it is important to understand maths behind machine learning is because if you don't know this maths, you won't be able to understand what is learning rate and where does it comes from, right? So you don't need to remember all this maths. You don't need to remember the equations. You just need to understand importance of learning rate, because when you will interact with Python, that's where you just get the option to pass learning rate, and the whole maths is pre-programmed. So the range of learning rate is always between 0 to 1, and we have to decide that value. You might say that, well, I want my learning rate to be very faster, but that's not the case which always works, right? Learning rate is like, let's say that uh, the way here, the goal is to minimize J by changing the values of MNC. Let's say I'm working in a company and I want to get a good hike in coming, the year end. So I would want to go to get good hike, and I'll go to my senior manager and say that, well, sir, tell me how should I get good hike? He's going to say that, go ahead and learn Java. What I'm going to do is I'm going to go to YouTube and watch a 5-minute video and say that I have learned Java. That's a very high learning rate. In 5-minute video, if I learned the whole Java, that's a very high learning rate. if I'm deployed to project, I'm going to make a lot of errors. So if your algorithm is using very high learning rate, the errors are going to increase. But let's say that if I take 5 years to learn Java, that also doesn't make any sense. So the learning rate should not be very low. It has to be tuned to right value between 0 to 1. We'll see in a scenario that how do we decide and how do we tune that. So learning rate is just an hyperparameter. There is no unit of it, and it's between 0 to 1. So this is the whole complete mathematics behind linear regression. There is no other maths in linear regression than this. And this is the maths for neural network, which is very popular algorithm also. The maths for neural network is derived from this, and which is widely used in deep learning as well. So this algorithm and understanding is very foundation for ML and deep learning. If you understand this very well, you will have a lot good help in understanding the rest of the other algorithms in machine learning and deep learning. Okay, so I'm going to take now questions on this and go and discuss those points. So why are we taking derivative cost function? So Mukul, I hope we have come to that point, right? Derivative part. So it's a partial derivative we're taking out, and that point is clear. So can you recall everything we learned till now before closing this session? Yeah, we are not going to have break, but we're going to have end maybe next 1 hour or something. So before that, Vinay, we're going to be having the recap of it for sure. Will you be teaching the data science workshop on 11th and 12th? Yeah, mostly I'll be taking, or there are other instructors who might take, but yeah, there are high chances that data science I might take. What is optimization problem? Whenever you wish to optimize any cost function or any error function or any other function to minimize value or maximum value, that's optimization problem. For example, here we want to get the minimum value of J by changing the value of M and C, but we don't know how should we change values of M and C. That's optimization problem. Learning rate. Yep. So learning rate is the idea of learning rate is it is about how fast your algorithm learns from data, right? And as a developer, we know the complexity of problems. So the fast at which algorithm, the speed at which algorithm can learn depends on the complexity. So we have to decide value of learning rate. It cannot be calculated, right? So there is a question: why LR ranges from 0 to 1? Well, that's if it goes lesser than 0, right? Mukul, imagine LR is exactly 0, right? LR is exactly 0. So can I say that new value of M is exactly equal to old value of M, right? In that case, old value of M, new value of M will not be changing. So you can say that if LR is 0, the algorithm is not at all learning anything. If LR is 1, M might reach out to 0. That's where we can't take anything between exactly 0 or 1. We have to take between them. In what terms LR is measured? No term, it's a ratio, you can say. On what factors is a learning rate determined, right? So it cannot be determined or calculated on any factors. It has to be tuned or hit and tried. So for yep, mostly I'll be taking data science workshop on 11th and 12th, or maybe other instructor. So there are high chances that I might take it. Will you take class on IoT vertical? No, I'm not sure if I'm going to take that, because on those dates I may not be available. So there are a lot of other instructors who might take it. Have you shared the screen? Yeah, it's shared already, Payal. I hope you should be able to see the screen. I am gonna kind of switch it off and on so that it should get visible. So kindly check out join again if it is not visible to you. Will we be following linear programming problems for minimization? Yeah, I mean, we'll be now, Samyukta, everyone, whatever mathematics we have seen, we are not going to believe this mathematics unless we verify this. So now we are also going to verify this maths. We are going to code this maths in Python and see that is it actually correct, right? Should I believe this maths or not? So we are going to programming, using programming, Python programming, we're going to verify this maths for sure now. So that's the next step. We're going to move from this slide, right? So in case you have not, you can take a snapshot of this slide in your smartphone, so that when we program, you should be able to, you should be able to relate that, well, this is how, the maths works out, and he's writing correct maths, right? So we're going to write this maths in Python to verify that does this maths work. Also understand the concept of learning rate. How do you tune that and how do you change it? Right. So now we're going to shift to Python programming. We are not going to learn Python. So in case you do not know Python, I'm really sorry, but yep, it's world's easiest programming language. And maths has no language, as we already know. So you will be able to understand the logic very easily. Right. So yep, that's the idea. Right. Let me take other questions. Can we use other function equation also other than line equation? Yes, other than that line equation also you can use. This is a very basic linear model. There are other functions as well available, Sanyam. Uh, how can we find LR? It has to be tuned, Rahul. The example that we see will be able to understand that very well. Why do we take a partial derivative instead of actual derivative? Actual derivative will show the change with respect to all the variables. Let's say actual derivative will show the change with respect to m and c both. But when I want to update m, I would want to have a change only because of m. That's where we take only partial derivative, right? If I take actual derivative, it will also create dc by dm as well, right? One more attribute. So if I want to have just see the just impact of one variable and all other variables I want to consider as constant, that's where I would want to go for partial derivative. That means logically I want to just subtract the impact made by m from the older value of m. Why I hope that we have answered your question as well, Mr. Hari. And yeah, we are going to shift to Python now. Rajat, can you provide study material on these things? Bhargav, yes, you can, get that out. Maybe you would receive an email having mention of those study material after the completion of this workshop, along with the certificate. Few topics on AI mentioned in the course content are not covered yet. Will you be covering later or no? So, Kusma, we're gonna now shift to Python programming. Maybe those topics is what we're going to check out now. Can I register for upcoming workshops as well? Yes, Anju, you can do that. They are on our website. You can go ahead and do that. What is M and C? M is slope and C is intercept of a line. These are two parameters in the line. Here we have seen that M is and C is M is intercept. So M is slope and C is intercept. Uh, ARCA pre-processing part we're gonna see not in this workshop, but yeah, in data science workshop we're gonna surely seeing up that. Okay, so here we are. I hope we're good with this part. How do we decide learning rate? Uh, we're going to see that out, Samyukta, in example we're going to see now, right? So now we're going to shift to Python programming. That's where we'll be able to decide that. Next 1 hour or 1.5 or more, Bhavishna will take this session for. Will Yes, Lavrens, it will be provided. How long we'll be doing hands-on today? Maybe 1.5 or more. All right, so let's switch to that. So the idea is now, everyone, we're going to be kind of, verifying the maths using programming. So if you have not written the maths, write it, or else take a snapshot in your smartphone so that when we write code, you should be able to verify the maths. Am I writing correct maths or not? Right. So we're going to verify this mathematics. This program is not to learn how to use machine learning. I mean, how to use linear regression. This program is just to verify our understanding and be sure that, well, whatever mathematics is being taught, it's correct math. And, the logic is correct and logic works actually. And so that's the only objective. This next code is not the code to understand how to do linear regression. We'll also see an easier way of doing linear regression where the code is or the mathematics is pre-programmed. Right, so let's get in that, and we're going to be using here one of the IDE called Spider. You can use any other IDE in case you are, you are into Python programming. If you're not into Python programming, don't worry about that. It's easiest programming language in the world. Yes, Anshu, you can apply another equation instead of straight line equation. Right, so we're going to be using a package called Theano for this. We're going to be also using NumPy. And matplotlib. You can use anything in case you want to use anything. You can use anything, Jupyter Notebook, anything like that. Okay, here we go. So Theano is a package which you're going to use for programming mathematics, NumPy, and matplotlib for visualizing data. Right. So let's say that we create some variables here. X is Theano dot tensor dot f vector and represented by x. Y is Theano dot. Because of scarcity of time, maybe we are directly looking at code, but when we actually work with some sort of courses or long-term courses, we discuss this in a very detailed way. But here, we'll be kind of going a little quick way with this, just to have the complete understanding of logic. Right. So let's say that the initial values of m is 0.5. We have taken randomly, and c is 0.6. and y hat is mx plus c, right? Now let's discuss it out what you have written in the code. Okay, so in case you got warning, you can ignore that in case you're coding it. If you're not coding, that's good. Let's see the code here. I would strongly recommend to see the code here. Later you can write the code, because if you're stuck in writing the code, you will not be able to understand the code. Okay, so yep, let's so yep, this program is for verifying the maths behind linear regression, which we have seen. And yeah, I'm going to share the code, Mukul, don't worry about that, right? So I'm going to share this code also right now as well and later as well, right? So X is Theano tensor. Tensor means any variable. So tensor means data type. Like in math, we use matrix and vector to represent data type, vector, matrix, scalar. In maths, we use it. Similarly, in programming, we use it array to represent data type. In physics, we use tensor. So Theano tensor, F vector and float vector. So X is a placeholder, it doesn't have any value. It doesn't hold any value at this point of time. And Y is another placeholder, we can say. M is a variable with value 0.6, 0.5, and C is a variable with value 0.6. Why have we taken M and C as shared variable? That we're going to look at later. Right, so initial value of M we have taken as 0.5 and initial value of C we have taken as 0.6. We have taken randomly, we have selected these values randomly because we know that gradient descent is going to be able to get the right value for us. Okay, and we have defined y hat equal mx plus c, right, and as the equation. Yeah, so Theano is a package for mathematical computation, NumPy is for mathematical computation, and Matplotlib is for data visualization. And these are three libraries that we are using in Python for this code. All right. So this was the idea of regression equation, right? So here we have coded the regression equation. So you can say that this is, if I comment it, this is regression equation. I'm putting comments over here. Now we're going to program the cost function, the error function, right? So we're going to be writing the error function or the cost function or the function, right? Which is going to be like this: cost. This is exactly equal to j equal 1 by 2n summation of y equal to 1 to n, I equal to 1 to n, y minus y hat squared. So Theano dot tensor dot mean Theano dot tensor dot square of y minus y hat by 2. So this makes it exactly that mathematical function 1 by 2n 1 by 2n summation of I equals to 1 to n y minus y hat square. So y minus y hat we have taken square, we have taken mean is comprising of what? Mean means some adding all the values, that means summation of I equal to 1 to n, and 1 by n is part of mean. As at the end we have 1 by 2, so it becomes 1 by 2n I equal to 1 to n y minus y hat square. Sure, Mr. Balaji. Okay. So yeah, that's idea so far. This is where we have programmed the cost function, exact cost function here, right? And so I hope we're good with this part, right? So this is exact cost function. You can match this, with this particular mathematics that we have seen. 1 by 2n summation of I equal 1 to n y minus y hat square. So we have programmed the cost function. Now our objective is to minimize this cost function by changing the values of m and c. And to do that, we're going to be using gradient descent, right? So there's a question, what is Theano? Well, Theano is a package library which helps in performing mathematical computation, right? It's a library which helps in performing mathematical computation. So here using Theano, we're defining some variables and some mathematics we are doing using that. How will you memorize all these functions of library? I mean, for me, it's everyday job of coding and development. So if you are in practice, you'll get to, remember these things. Can we use pandas instead of Theano? No, pandas has completely different job, Arka. We're going to be using that as well, in maybe in next 10 to 15 minutes. But that has job of import, data import, export, cleaning, manipulation, things like that are doable with pandas. We're going to take, we don't know the value, we don't know the right value of learning rate. So here, we're going to take a randomly value, let's say 0.3. I think my audio got disturbed sometime back. I hope I'm properly audible now. Right. So yeah, so let's say that we're gonna now going ahead and applying gradient descent algorithm here. Right. And we have taken a particular value for learning rate. Let's say that's 0.3. Now, 0.3 may not be the good value. We're just taking it and we'll change it if it's not good. Right. There's a question, why are we using Python instead of Java? Well, Java is development and Python is for data science. It's good for data science. It has good packages for data science applications. So it's Python is more preferred over Java for data science and machine learning and AI, deep learning stuff and all. So can you explain what is this line statement Theano.tensor.f vector? Well, this line is much more like creating a variable x. Actually, this line is much more like creating a variable x, which can hold a float vector. That means it can hold float values. We are defining that as a limit. It can only hold float values, and the vector. Vector means set of values, right? So we're just defining a Theano type of variable, which is f vector, float vector. The meaning of tensor is just the data type. The meaning of tensor means data type. So I can have a tensor of, let's say a vector is a tensor of dimension 1, a matrix is a tensor of dimension 2, a three-dimensional matrix is a tensor of dimension 3, right? So tensor means data type. For example, data can be represented in an integer, string, float. Like that, Theano in physics, the data type is called as tensor, right? So a tensor of direction 1, tensor of dimension 0, tensor of dimension 2, tensor of dimension 3, like that. Float vector is a tensor of dimension 1. All right, so coming down here. So we're going to be applying up now the gradient descent, right? We have defined the learning rate here. First, let's calculate the grad m and grad c. Grad m is Theano dot tensor dot grad, that means gradient of cost with respect to m. This is like calculating what? Del j by del m. We are calculating that. Grad c is Theano dot tensor dot grad of cost with respect to c. This is like calculating del j by del c. Then now apply gradient descent. Here comes the gradient descent. New value of m equal old value of m minus learning rate multiplied by grad m. New value of c equals old value of c minus learning rate multiplied by grad c. Right. So at this point we have to program the gradient descent. So at this point we have programmed the complete mathematics behind linear regression. Are we good so far? Any questions that you have? There's a question. For x equal to 0 also represents float number. Is this similar to x equal to Theano? Yeah, I mean x equal to 0.00 represents float number. It is similar to x equal to Theano dot tensor dot f scalar. Right? A vector means a set of values. Okay, but at this point you have to define only Theano variables, right? Because we are doing computation mathematics using Theano. Right, so are we good so far till here, everyone? Any question that you have? There's a question. Please explain. Excuse me. excuse me. Please explain why you have written zero point 0.5 and zero point 0.6. Well, Rajat, that I have taken initial values of MNC. As we know that in every iteration, the values of MNC is going to change because of gradient descent, right? MNC is going to update because of gradient descent. Gradient descent is going to change the values of MNC to bring cost function minimum. So initial values of MNC, I can start with any random value. So 0.5 and zero point 0.6 are randomly picked. You know, you can also think of gradient descent as like a kid is going to school to learn ABCD. When the kid goes to school on the very first day, the kid's brain have random values of parameter. That means the values of MNC in the kid's brain are random. That means kid doesn't know anything about ABCD. At the end of the school, the kid's parameters are optimized. That means the values of MNC are optimized. That's where kid learns very well how to recognize ABCD. So initial values of parameters could be any random values. And that's where we have taken 0.5, 0.6, right? So gradient should be able to change it to and bring it to the better value. So we've taken random values, believing that gradient should be able to change it out. I hope that answers the question, Rajat. What is Theano shade? That's a good question, Bhavishna. What is shade? Why have you taken shade variable? That's a good question. So we're going to discuss that answer to this in next line of code we have right here. All right. So other than that, I hope we good so far here, everyone. Other than this Theano shade, which we're going to discuss here. Right. So now we're going to wrap this up, the whole thing, into a single function and use that function for training the model. This question: why do we subtract instead of adding the part of get new values of MC? Samyukta, that's where we don't have to subtract always. It's like you see, in case the requirement is to add it, the value of grad m and grad c will be negative. If the value of grad m and grad c is negative, m and c will be added, right? So we don't need to worry about we are subtracting or we are adding. It sometimes get added or sometimes may get subtracted according to the demand, according to the pattern observed in the data. Right? If the patterns are high, the values of grad m and grad c will be negative. If the patterns are like other ways, it can be positive. Right? So the tuning of whether to subtract or add will keep on happening automatically. Okay, so let's wrap this up. The whole thing: create a Theano function. Create a Theano function. Right, create a Theano function, to do the complete job, complete maths. So let's say train is the name of function, is Theano dot function. So in this whole programming process, everyone, in this whole programming process, which variables represent the data point, right? Area and the price, right? What is the data that we're going to feed to train the model? Area and price. Which variables represent data? Which variables we are going to feed as a part of data? In this whole algorithm, right? Mathematical algorithm, if we have to train this with the data, which variables represent input data? So can we say X and Y represent input data? So here we'll mention inputs equals X comma Y, comma, we'll mention outputs. Let's say that in output, we want to see that how much cost function is decreasing. That means how much error is decreasing. So we have to feed that as output, right? So, we have to understand that as output. So we'll say that cost is output from the whole function. And we want to see that in every iteration, how much error is decreasing out. Well, other than that, can we say one thing, everyone? Now, this is very important. Can we say that in every iteration, in the first iteration, whatever the new value of MNC we get should become the old value of MNC for second iteration? In the first iteration, whatever new values of MNC we get should become the old values of MNC in the second iteration. Can we say like that? Right? Can we say in the first iteration, whatever new values of MNC we get should become the old values of MNC in the second iteration? I hope all of you agree. Right? Right. So the idea is that whatever the new values of MNC we get in the first iteration should become the older values of MNC in the second iteration. Whatever the new value of MNC we get in second iteration should become the older value for third iteration. So in every iteration, the values of MNC has to be updated. That means the values of MNC has to be shared between multiple call of the function. That's the reason we have taken MNC as a shared variable. Bhavishna, I hope this answers the question. Why have we taken MNC as a shared variable? Because values of MNC has to be shared between multiple calls of the function, right? So here we'll write that updation m comma mn comma c comma cn, right? That means mn will be updated to m and cn will be updated to c. This is the whole segment where we have programmed the complete maths and program about linear regression. So our algorithm is ready in the form of this train function. Now we need to have data and we can train the model with the data. Let's do that here. So let's say that we're going to calculate data. We're going to get data here. So I'm going to just pick some random data here. Right. So let's say that area, I'm going to take data in the form of some 1,000 square feet, right? So multiplier of 10 to the power 3, right? So 1.2, that means 1,200 square feet. 1.8, that means 1,800 square feet. 2.4, 5.6, 3.5, 4.6, 7.8, 6.2, 3.4. And the price for respective in the 1,000 lakhs, 100 lakhs somewhere, right? So 1.2 is 240, that means 24 lakh. And 1.8 is let's say, or 240 is a little high, let's say 180, 18 lakh. And this is 240, 24 lakh. And 270, 27 lakh. 480, 48 lakh. And 310, 31 lakh. 42 lakh. And 68 lakh. And 66 lakh. And 42 or 43 lakh. Right, so that's random data we have taken area and the price. So we want to train our model using this area and this price, right? So we'll do that here. So we'll convert them into a first numpy array. So area is numpy.array of area.as type float32, because Theano always expects the data into float32 format. Price is equal numpy.array. So our data is ready and our algorithm is ready. The time is to train the model with this data. Right, our data is ready, our algorithm is ready, and time is to train the model with this data. Okay, here we go. So now we're going to train the model. We're going to train the model 5 times. So for that, we're going to use for loop. For I in range of 5 times, we're going to get cost val equals to, going to call this train function. You see, we're going to call this train function, which is going to do the whole maths for us. Train function. And I'm going to pass area and price as input. Instead of x, we are passing area. Instead of y, we are passing price. And just printing the value of cost val. So you're training the model 5 times, and just every time in every iteration, we are analyzing the cost function. Let me execute this. So this is the value of error or the cost function in the first iteration. This is the value of error in or the cost function in the second iteration. Error in the third iteration, error in the fourth iteration, error in the fifth iteration. So when the model learns from the data, the error should increase or decrease. And is it currently increasing or decreasing? What should be the ideal scenario? In every iteration, the error should increase or decrease. And what is happening right now? Right. So in actually, when model learns from the data, the error should decrease. And what is happening right now? Is the error increasing in every iteration or it is decreasing in every iteration? Right. Currently error is increasing, but ideally it should decrease, right? That's how the learning process comes into picture. So currently we can see that from first to second iteration, the error has increased like that, but ideally it should be decreasing. That means the model is learning in a wrong direction. So one of the reason why the model might be learning in wrong direction is because the learning rate is very high. So I need to decrease the value of learning rate from 0.3 to 0.2. So I will go to 0.2, and now I again will check it. So is the algorithm still the error is increasing or error is decreasing? So we can say that still error is increasing. I will need to reduce the learning rate even more, 0.1. Let me train the model again. Now still error is increasing or decreasing? Looks like error is still increasing, but very less. Now very slightly increase in error is there, but ideally it should decrease. So we need to decrease the learning rate even more, and I'll make it 0.08. Let's see now. And now we can see that error is decreasing. That means the algorithm is learning in right direction, right? Ideally the error should decrease, and that's happening now. So this is how we have tuned the value of learning rate. Learning rate value cannot be calculated. It has to be always tuned. It has to be always hit and tried like that, and you have to tune it to the best value. Okay. At a later stage, there are some mathematical ways of automating this tuning process. At a later stage, if you learn more into this, you'll find that there are some mathematical ways of automating this tuning process via momentum and via other mathematical techniques. But yes, in general, it cannot be calculated. It has to be tuned out. So we got better value of learning rate now. Once we go to the value of learning rate, if I want to decrease the error further, I can make the algorithm learn more times. Let's say I can make the algorithm learn 50 times. I can make the algorithm learn for 50 times, 50 iterations. Oh, what is happening? Where is that? Line 1. Oh, I have written A here. So now you can see that error is further decreasing out. If in 50 iterations I'm not achieving good value of error, so it's going to go further down like this. Right. So this is where error is very less, and further decrease in error is very less also. This is where I can stop. Right. When the further decrease in error, you can say that further change in error is very less. That's the stopping criteria. This like I start to learn to drive a car. First day I learn a lot, second day I learn a lot, but after 5 years of driving car, the amount of learning that I make every day is negligible. So at that point, we can say that we are a trained model. The same way, when the algorithm makes learning, the further decrease in error is negligible. We say that, well, this is the point we have achieved learning. Dikshit, in case you are receiving that error of no module found named Theano, can you help me out with the IDE that you're using? Are you using Jupyter, Spider, or ideally? Yeah, 0.01 is also good, but Mukul 0.01 will be very slower compared to 0.08. If the model works good on 0.08, I should consider that. Right. So Dikshit, any idea you're using if Theano is not installed, or if you're getting error like Theano not found, so you can write this command, make sure internet is connected, pip install Theano, exclamation mark, pip install Theano. The recording of session you can get maybe the recording is being done, but you can get the recording mostly from the point of contact you have from the TechTrunk Ventures. Maybe they can help you out with that. Yeah, so for what 0.07 we can change it to 0.7 will be very high. So Dikshit, this will help you out with the installation in case you have an error installation, right? Exclamation mark 0.07. Akshat, in case you are asking about recording, you need to connect to someone in your point of contact at TechTrunk Ventures, and they can help you out with that. Okay, so 07, you want me to try out with 07, right? So yeah, with 07, let's say that right now it is decreasing up to 1075 into 7284, 0.7284. 7288 with a lesser value of learning rate. Earlier it was 7284 in 500 iteration. Now it is 7288. So there's a low decrease that we have, higher error we have. So if you have very lesser value of learning rate and at a certain iterations, we'll not be able to achieve good performance. So you can say 0.08 could be a better learning rate compared to 0.07. I hope we're good with this, Fawad. And is it better to increase the number of iterations or decrease the learning rate? It is better to increase the number of iterations. Having good balance of both of them gives us better performance, right? In case you want to see now whatever the best values of MNC, you see values of MNC we started from 5.6. If we now print the values of MNC, the value of M is 78 and print the values of C, the value of C at this point is 90. Right, so value of M is 78 and value of C is 90 after training the model, right? If you want me to draw this, yeah, Ruhan, Ruhan, at a later stage, there is a way to automate the learning rate process, right? So yes, it is possible to automate identifying learning rate, but that's a later stage. That's a little bit more mathematics can do the job. Okay, so let's say that if I try to draw the old line could be area into 0.5 plus 0.6, and new line equals to area into m dot get underscore value plus c dot get underscore value. Right, so these are the old and new line we have. Then I can simply do pld dot scatter area and the price, just to draw this, just for the logical understanding. Color is red, pld dot plot, color is green. So this is how we can see the trained model. The untrained line is the red line, which is the old line, which was with M and C is 0.5, 0.6, and the green line is the best fit after training the model, which has minimum error, right? This is just to understand the logic and the process only. Okay, I hope we're good so far with this. Right, so here we have written the complete math and we have verified the complete maths. The same way, every time you don't need to do this job, and we have also the functions which has the complete maths pre-written with them, and that's why we don't have to do anything into it, right? So Python has such good packages which can do the whole maths on its own. Before that, let me sort of send it this this code to all of you. I hope you all have access to chat box. Right, so I'm going to put the message in the chat box. And on that, also these documents will be shared with you over email as well, the code document. So well, this was sort of idea of how do we do it with Theano and with manual and encoding. And in case I want to do it with shortcut, I have also other library as well. In beginner, as a beginner, you can start with other easy libraries, right? So they are good libraries as well available. For example, Let's say I can import NumPy and import matplotlib. In a new code, I'm doing this .pyplot as plt, and I can just say that this is my data. I can say that I have to just pass area as a 2D format. I might not need NumPy as well at this point in time. I need to pass area as a 2D format here, and just I can directly import from scikit-learn dot linear model import linear regression. So this class linear regression has complete maths provided into that. So I don't have to write maths in this case, right? So I'm using, instead of Theano, I'm using other library. So in this library of scikit-learn, I don't have to write any maths behind the algorithm, and I can get the complete maths behind the algorithm pre-written inside it, right? So I can just train the model, create the model using linear regression and train the model dot fit area and price. That simple and straightforward it is. At this point, you're done with training the model. Oh, it says that found input variables with inconsistent numbers. What is that? Length of area. Okay, my bad. I need to kind of convert this into numpy.array. Dot reshape into 1 row and 9 rows and 1 column. So at this point, I'm done with training the model, and very simple. I can get the new values of M and C, get the new values of M and C, model dot print value of M as model dot coefficient. This is the value of M. We got 78, and similar way we can get the values of C as well. Value of C as this. It's very straightforward. If I have to make a new prediction for house, with area, let's say 2200 square feet. So I can simply say that model.predict 2.2, and it can make a prediction 2200 square feet is going to have 26.2 lakh. 26 lakh, 25,000, 8,600, something like that. It can make a prediction. So it's very straightforward, to make a prediction like that. And with scikit-learn, it's quite easy. So scikit-learn is also library, libraries, like the way we had a library Theano. It's also a library in Python, which has all the machine learning algorithms pre-programmed available, right? So why do you use 9x1? Because it's 9 rows and 1 column. Scikit-learn always expects Samyukta data into 2D format. So we are saying 9 rows and 1 column. So scikit-learn is a library in Python which has all maths behind all ML algorithms pre-programmed. That's where you don't need to remember maths. You see here, we have not coded the cost function, gradient descent, nothing like that. It does everything backend. But yes, one should know the mathematics, but in real application, you can use scikit-learn to do the job. Right. So that's the idea so far about, how do we implement this with scikit-learn without writing maths? Are we good so far? Let me know. Okay, so now, in a quick go, I'll not take much of your time, just 30 minutes more max. And in a quick go, we're going to see one real world example. All right. So I'm going to take you to a particular place where we can get certain data, and that's where we'll take hardly 25 to 30 minutes max. And that's where you're going to see a quick example. And then we'll be able to end up the session. PyPlot is a segment of matplotlib, which is used for data visualization. Okay, so if I go to Google and search for UCI machine learning, UCI machine learning. Right. I get this repository, UCI space machine learning repository. Yeah, I can send you the last written code, Kripa. Just a moment, I will do that here. Okay, so UCI machine learning is a repository for a lot of data sets on which you can apply machine learning. And this data set is hosted by University of California at Irvine. So University of California at Irvine provides this repository on which you can get a lot of real world data for free. Okay, so we can also get data sets from Kaggle. Kaggle is also a good source for getting that. Right. So we're going to click on view all data sets. Right. So this is all data sets we have. You can see that here you can get a data set for classification, regression, clustering, anything. So let's say that we are solving a regression problem. I'm going to click on regression. And in this, we have a lot of data sets for regression on which we can apply regression. Let's say 3D road network, air quality, airfoil self noise, Amazon access sample, appliances energy prediction, automobile behavior of urban traffic, Beijing bike sharing data sets, breast cancer, buzz in social media, carbon nanotubes, cargo 2000, Challenger USA space shuttle O-ring, combined cycle power plant, community and crime unnormalized, computer hardware, concrete compressive strength, and condition-based maintenance of naval plants, and container crane controller data set. Well, a bunch of them we have data sets available here. Well, we're going to work on this one, combined cycle power plant. Combined cycle power plant. This is the data set we're going to work and build on the real use case. We're going to develop a scenario. Develop a model for this. So combined cycle power plant. Let's understand the case study here, and then we'll solve this. The case study is the data set contains 9568 data points collected from a combined cycle power plant over 6 years. That means from a combined cycle power plant in past 6 years, some data was collected. They collected around 9,568 data points. They collected it from 2006 to 2011. When the power plant was set to work on a full load, that means power plant was working with a full capacity. Let's see it further. It's for regression problem. Number of instances are 9568. That means 9568 rows. Number of columns, features are 4. It was generated by Namık Kemal University from Turkey and another university from Istanbul, Turkey. These two researchers donated this data set. Okay, they prepared this data and donated this all. This data set is collected from combined cycle power plant over 6 years. All right, we'll download the data. We'll see the data. Right now we are reading the description. We will see the actual data as well. When the power plant was set to work with full load, feature consists of hourly ambient temperature. So the features consist of variable temperature, pressure, humidity, and exhaust vacuum. And the object is to predict the net hourly energy output of the plant. So energy output of the plant is something what we have to predict. Right. So combined cycle power plant is composed of gas and steam turbine combined together, and using some sensors they collected some data. So the idea is that there is a combined cycle power plant, and in 6 years they collected that when we operate the power plant on this value of temperature, pressure, and humidity and vacuum, this is the power produced. Like that, they collected data for 6 years. After 6 years, now they want to have a model, a machine learning algorithm, which can help them to predict if they operate plant on a particular value of temperature, humidity, pressure, and vacuum, how much power they should expect. So our job is to use their data and develop a model to predict on a given value of humidity, temperature, vacuum, and pressure, if they operate the plant, how much power produced they should expect. Right. So the attributes are, we have temperature in range of 1.81 degrees Celsius to 37 degrees Celsius. Pressure in another range, humidity we have, vacuum we have. And finally, we have net hourly electrical energy output of the plant. Right, and so
So there's a question here. It's mentioned it's a regression problem. What if we don't know? We'll talk about that. Now we'll talk about that. What if it's not mentioned? So let's go to data folder. So we go to data folder. I just clicked on this data folder option. You see, I clicked on this data folder option, and I can see that there is a zip file. I can download it. I'm gonna click on this zip file. It's gonna download the zip file. I have already downloaded that, so I will go ahead and open that for you. Okay, so I'm gonna go to the options of quick access and maybe the PPTs or maybe the ML and maybe the TS sets, and I have. So this is the data that we have. You can download that from there as well. So this is the data that we have. You see a repository, Bhavishna can be used for downloading data sets. That repository hosts hundreds of data sets for machine learning use cases. So you can use that for downloading data set and also uploading your data sets as well in case you have created some. Right. So Harsha, answer to your question is, here we have features, right? So we have features: temperature, vacuum, pressure, and humidity. And our object is to predict the power produced. So our label is power produced, P column, right? P column is our label. Based on temperature, vacuum, pressure, and humidity, we have to predict power produced, right? So here, this is the label. The label is a continuous variable. This is a continuous variable. If the label is a continuous variable, the value that you're trying to predict is a continuous variable, the problem is a regression problem. If the label is a categorical variable, the problem would be a classification problem. As you can see in this case, the label is a continuous variable. So the problem is a regression problem. If it would have been a categorical variable, the problem would have been a classification problem. By looking at data, by looking at label, we can say like that. I hope that answers the question, Harsha. Right. And Lavrens, there's a question from Lavrens, which is like, how can we find which type of regression we should use? Well, that depends on the feature engineering you do. Like there's one of the very popular mathematical analysis, which is what we call correlation analysis. So correlation helps you out to identify that whether data has linear pattern or non-linear pattern. And based on that, you can further decide that which algorithm is better. But that's not the under the scope of this, you know, workshop, I mean this particular workshop, otherwise you could have kind of covered that. Okay, so here we have temperature, vacuum, pressure, and humidity to predict the power, power produced, the fifth column. So objective is to use this data, train the model, and build a train model to predict this out. Let's do that. So in order to load this data, I'm going to copy the path for this. Copy as path. I'm going to take a new program here. We're going to use pandas. I'm going to use numpy. I'm going to use matplotlib.pyplot splt. Right. So let's import the data. So data frame equals pandas.read Excel. So you see pandas has options of reading data from CSV, Excel, feather file, FWF, GBQ, HTML, SDF, JSON. You can read data from multiple sources using pandas, SQL databases, everything. So we're going to read it from Excel. And I can pass here the complete path of the file. Oh, I forgot to execute this. It says that, okay, it's a CSV file, not Excel. I need to mention here CSV. In case you're dealing with Excel, mention, or let's say that let me, to here, Excel 6. I kind of need to copy this path. CSV stands for comma separated file. Here I have that file ccpp, and this is the file I'm going to get. Copy as path. Okay, let me put here read CSV itself looks like. Okay, so here we are able to load the data, right? If we want to see that out here, we can go to Variable Explorer and see this. Here we have downloaded the data. So we're able to load data, AT variable, a temperature, vacuum pressure, humidity, and power produced. We have predict, right? So we can do a lot of feature engineering. This is not a good code that we're going to write. Now we could have done a lot of analysis on this data before we proceed ahead from machine learning. But as I just wanted to show you a real-time example, I just wanted to include this out. As there are four features, the equation will look like y hat equal to m1x1 plus m2x2 plus m3x3 plus c. Sorry, plus m4x4 plus c. All right, so here we will go ahead and separate our features and the label, and then we'll train the model. All right, we'll verify the performance of model based on the test data. So we'll split our data into train and test, and then we'll kind of verify the performance of model on the test data. Right, the code has, this line has loaded the data set. We are trying to import the data, so we have imported the data set in the programming environment. So you can see the same data is now available with df: temperature, vacuum, pressure, humidity, and power produced. Now nothing will happen with data. We're just going to use this data set and build a model out of it. Okay, so let's separate features on the label. So you can say x is df of p column, sorry, df of you can say uh, at comma vacuum, right? So that's how the columns are, right? At, vacuum, ap, and rh. And y is df of p column, which is the power produced. So we separate our x and y here. Right, now we're good to go ahead and build the model, right? But if we build the model, the question is that how will we assess the performance of model? That's a big deal here, big question here, right? How will we assess the performance of model? CSV stands for comma separated values, right? The question is that if we train the model with this data, how will we assess the performance of model? It's like what? Let's say that there is a healthcare client, and the client has given us data of 10,000 patients, saying that, well, go ahead and build a model to predict whether these patients will have diabetes or not, right? So that's what you have to do. The client has given us data of 10,000 patients. Now, being data scientist, what you can do is we can train the model, and we can get a good model to make a prediction. But we are not doctors to say that, well, this model is good, and you should kind of go ahead and trust this out and use this in production, right? We can't say that this is a good model and you should go ahead and you know uh, use this in production, right? That's where what we can do is out of that 10,000 data, we can use 8,000 data and 2,000 data separately. We can use data of 8,000 patients to train the model. We still have data of 2,000 patients and their answers. To the trained model, we can pass the questions of those 2,000 patients and get the answers. Compare the answers with the right answers, predictions with the right answers, and say that, well, the model is this much accurate on the unknown data. The model is this much accurate on the unknown patient's data. And this is the accuracy you should expect in the production. So the idea is that out of the whole data, split it into two segments, a big segment or a larger segment called trained model, training segment, and the testing segment. Train the model with the training data set and test it with a testing data set, right? So that's how we can assess the performance of model much better. So there's a question: why do you put x in double square bracket and not x? Why? So because whenever I want to get one column, I can use single square bracket, but when I want to get access multiple columns, I have to pass two square bracket, or you can say technically it is passing list of column names. If that answers the question, Fatima, right? So whenever I want to get only one column, I can pass single square bracket. Whenever I want to access multiple columns, I have to pass list of column names. And for that, we have to pass two columns. I mean, two square bracket. All right, so good we are. Let's go ahead. So what we're going to do is we're going to split the data into train and test sets. So let's say 80% for training and 20% for testing. For doing that, we'll do random split, and for doing that, we have ready-made function available. From scikit-learn dot model selection, import train test split. I can use xtrain, comma, xtest, comma, ytrain, comma, ytest equals train test split x and y, comma, test size, we can mention 20.2. That means 20% data we want to have test, and rest into train. So this is how I can get train and test split data, right? Scikit-learn dot model selection train test split, and we can get here the data split into train test segment. Now we can use xtrain and ytrain to train the model, and xtest and ytest to check the performance of model, right? So there's a question, why are we splitting data? Well, we are splitting data so that we can have a larger set which we can use to train the model and a small set to check the performance of model. It's like what? If my teacher is teaching me maths, so the teacher should not ask the same questions, whatever question teacher is teaching me, the same question should not be asked in the exam. There should be different questions asked in the exam. So out of the whole data, we have trained, for training the model, we have kept 80%, and for testing, we have kept 20%. So 80% of questions we're going to use to train the model, and 20% of the questions, or you can say data points, we're going to use to check the performance of the model. Right, so that's why reason we have done the splitting. I hope that answers the question, Lavrens. Well, what is pandas? Pandas is a package used for data import, export, manipulation, cleaning, filtering, analysis. There's a question, why specifically NT20? Well, Samyukta, this is a popular split. I can also use 90-10 or 70-30, 95-5, anything. It's up to us. How we define a model? A model is an algorithm which can learn from data. So you can say a machine learning algorithm plus data is a trained model. I hope that answers the question, Srihari. All right, let's go next. We're gonna now training the model. Train the model, train the model, train the model using data. So from scikit-learn dot linear model, import linear regression, and we can say model equals, model is just a variable here. We could use anything else as well instead of that. Scikit-learn is a library, a package like Theano, like NumPy. It's a library in Python, which is used for machine learning. So at this point, we have trained the model. The model is trained to make any prediction. Right? A model is a general purpose variable. I could use ALG or model 1, model 2 as well. Linear model is a category inside scikit-learn. Inside that, we get a lot of linear models or linear algorithms. Right? Here, this model is just a variable. I could use Unshu as well. Unshu equals to linear regression, Unshu.fit. That will also do the job. Right? This is just a variable. Linear model is like a set of linear algorithms inside scikit-learn. Scikit-learn has both linear and non-linear algorithms pre-programmed. Okay, so now we have trained the model, right? That means, everyone, that means if I make a prediction for this one, let's say, for this, if I feed these values to model, right, this value of temperature, vacuum, pressure, and humidity, it should make a prediction somewhere closer to 453, right? It should make a prediction somewhere closer to 453 if I feed these values as 19.07 and 49 and all. Let's try it out. If we feed these values, it should make a prediction closer to 453. Let's give a try, right? So let's say that, a variable A is something we have taken these values, or A is numpy.array dot reshape 1 row and 4 columns, and we're going to pass these 4 values. So if you pass this data to model, it should be able to predict a value closer to 453. So it says 455.69, which is quite closer to 453, as you can see. The actual value was 453.09, and the prediction is 455. Quite closer to that, we are getting a prediction. Right. So this is how, if we feed any set of data to the model, it will be able to make a prediction. Right. NumPy is a package for mathematical computation in Python. It is used to handle mathematical data types and also perform mathematical computation. So this one is an example where you can get a trained model, and you can kind of use that in production. So now let's check the performance of model. On test data, how good or how performing model is. Right. So now we can check the performance of model. So for the test data, I can get ypred is, or I can directly pass it model.score. What is the score of model on the test data? X test and Y test. The score of model, how good the model is. So model is 92%, 0.92 in the sense 92% good on the performance of model is 92% good on the test data. On the rest of the test data, if we check the closeness of predicted values to the actual values is 92%. So the model is 92% good on the test data. Well, this data was very simple and it was easy to achieve 92% of performance. But in general, in real world, it's difficult to get that sort of performance with a real world data. Yes, I'm going to share this real-time code as well. Let me do that. I'm going to copy this out and put that here. And also I'm going to put that in chat box as well. Okay, so I hope we're good so far. Okay. How can increase the performance of the data? By making the data more accurate, maybe scaling the data can help us out as well over here. In this example, we are not setting the value of learning rate. It is being set implicitly, yes. But actually, this is using a little statistical approach for doing that. So yes, we are not setting up that. It is using a little different approach compared to gradient descent. Okay, so I hope we're good so far with this. All right. Okay. All right. So, well, this was sort of idea of this workshop, and we have seen so far the idea of artificial intelligence, machine learning, deep learning, the idea of ML, the understanding of data science, natural language processing, computer vision, and the idea of supervised, unsupervised reinforcement learning, clustering, anomaly detection, recommendation system, classification, regression, the idea of linear regression, the maths behind that. We verified the maths. We have seen an easy way of doing that, and we have also seen the idea of working with this combined cycle use case as well, combined cycle power plant use case as well, right? And so yep, that's that sort of idea so far. And let's now kind of look in the idea of just a moment. So we're gonna be right. Okay, I'm gonna be just, so we have a couple of questions. We're gonna take those questions over here. And just before that, give me a moment. I'm taking a couple of questions, just a moment. Okay. And so yeah, let me take that out. So here is a question regarding the line number 34. So line number 34 is about creating a given input values, right? So for a value, here you're just creating an array for given input values of temperature, humidity, pressure, and vacuum. And for these values, you want to predict given, for these values, what should be the power produced. That's something that you want to predict over here. Okay, I hope that answers the question, Mr. Muthu. So here, this is the temperature. These values we took from this particular data set here, 19.07, 49.69, and 1007. And of these values, you want to create a numpy array of shape 1 by 4, like that. So, well, that's idea so far about it. Will you be able to answer queries if I have any in the future after the end of workshop? Yeah, you can always reach out to us on our YouTube portal and Facebook portal as well for any such queries, and also support we have. Well, teachers logistic regression, not in this, but yeah, you might get to see that in data science workshop. So we also have a couple of other workshops. There's a question I missed half of the webinar. Is there any other day where I can do everything and from start, or is there another way I can start from this start? Well, Tejaswini, you can request for more details and the data support from the support. Other than that, yeah, like we have coming more workshops as well, which should be able to help you out with this thing, right? So I think that should be helpful, right? And yep, we are going to sort of conclude with this point. And before that, I have sent you a link for feedback. So I'll request all of you to put your feedback on this link, which I have shared in the chat box and also in the question box as well. And reshape of 1 by 4 is for 1 row and 4 columns. Right. So yeah, we have a lot of courses. Before that, I would take you through the workshops that we have. Right. So we have these set of workshops with us as a part of just a moment, TechTrunk and workshop series. So you can reach out to these workshops. We have some of the workshops. And that we have a lot of courses. So we have courses on which are instructor-led and self-learning courses. Instructor-led courses will be taught live, like the way we have this workshop. You have live instructor, you can ask questions. Self-learning courses are the videos, recorded courses, and you can access them anytime, anywhere you want, right? So we have self-learning courses as well, and we have instructor-led courses as well, right? So you can, for any more detail, you can look at the variety of courses that we have. For instructor-led courses, we have robotics process automation. We always have discounts happening up. So maybe for festival like Raksha Bandhan and Independence Day, you might get some of the discounts coming up. And so yeah, you can always reach out to the sales team and the support team for discounts on the courses. So we have artificial intelligence, Internet of Things, data science courses in more detail. We also have like the courses which are self-learning courses as well that you can reach out. Right over here, we have Python free courses on robotics, and some of the free courses are available, some of the paid courses are available as well. Coming up, we have also coming more workshops, right? So in case you are interested into more workshops, I think we have more workshop series which you can kind of get into. So like today we had a workshop on AI and machine learning, which is on 3rd and 4th August. We have more workshops on 10th and 11th on data science, then IoT on 17th and 18th, and robotics process automation 24th and 25th. Right, so we have more workshops coming up. In case you are interested, you can also participate in the rest of these workshops as well, which are free. And yeah, so you will get certificate for this, which will be dropped as an email to your email ID. And yeah, that's idea. You can refer to this particular link for more workshops. Right, so and in networking, we don't have as of now any workshop coming up, but yeah, we may have that in future. And for recording of session, you will need to connect to the support team, and that's where you can get more details about that. So you can get into the, in case you are interested, you can look at these details, these courses. These courses teach, the instructor teach the content from very scratch. Even if you do not know Python, this content will be taught with very scratch. Python programming is also taught in very scratch, and from very scratch to the end. And many of the courses are 3 months long courses, which take you through from basics of data science to natural language processing to computer vision, deep learning as well, and help you out to work on real-time projects. right? So for more details on that, you can request an email and the content on the courses, right? So I'm really sorry on about I will not be able to include much of the topics which are being asked here as a new topic, so which is out of the scope of this workshop. But yes, we would love to have similar requirements. You can always drop your requirements on to us on contact@techtrunk.in, and you can reach out to us on this mobile number as well. And we will try to organize similar workshops on the other concurrent and popular topics which are happening today in the market. So yes, we are going to conclude the workshop now. Thank you all for joining the workshops, and I hope you would have enjoyed and liked it out. And for IoT, we have workshop Akhilesh, and that's on I guess 17th and 18th. You can reach out on that, right? And for more details, visit our portal. We have free courses as well. You can always look into a couple of free courses to learn Python and learn robotics free on our portal, and enjoy learning as much as, right. We also have a lot of good videos on our YouTube channel. You can subscribe us on YouTube as well for coming videos, and maybe the videos of this may also be available out there. Certificate will be made sent to you via the portal, and the email you will receive that, and along with the certificate you'll also receive the content, the course that you have done in this class. So thank you all for joining. Hope you would have enjoyed it, and please drop your feedback on the provided link, and yeah, maybe see you in the next workshop. Thank you. Bye bye. Good day.